we start, we'd like to acknowledge the traditional custodians of the land and pay our respects to the elders, both past and present. Ladies and gentlemen, distinguished guests and participants from around the globe, welcome to the 6th International Webinar on Construction Materials. Today, we are gathered here virtually to celebrate the power of collaboration and exchange ideas that will shape the future of the construction industry. This webinar serves as a platform where experts, researchers, industry professionals, and enthusiasts alike come together to explore the latest advancements, techniques, and best practices in construction materials. Throughout the day, we'll be delving into various topics ranging from sustainable construction materials, innovative building technologies, emerging trends in material science, and much more. Our esteemed speakers and panelists from around the globe will share their valuable insights, shedding light on cutting-edge research and practical applications that will redefine the way we construct our built environment. The theme of this year's webinar is Building the Future, exploring sustainable and resilient construction materials. We recognize the urgency needed to address the environmental challenges, minimize carbon footprints, and ensure the longevity of our structures in all. Throughout this theme, we aim to inspire discussions and ignite transformative ideas that lead us toward a greener, more sustainable future. We're privileged to have an exceptional lineup of renowned experts and thought leaders from diverse backgrounds who will share their expertise today. Their presentations, case studies, and interactive sessions will undoubtedly enrich our understanding and inspire innovative approaches in the field of construction materials. Again, thank you very much for being here. And let's pass you on to our first speaker. Now, we have had some technical issues and we have actually missed recording the beginning of his presentation. So unfortunately, it will cut in. But here we go. This is Richardson from the US. He's here from Haven Earth. The founder, the co-founder. We'll let you take it away. Thank you, River.
Needs to be dialed in that respect for the region, and a lot of nations are still working with the right seed genetics for their location, because the history of this plant, a lot of that knowledge and a lot of them seeds were lost during, especially in the US, how it was outlawed for the last almost 100 years. So it's really coming back now, and it's taken off in the US like nowhere else in the world. I think when the US gets into something like this, it has a real momentum to move to the next level. And these materials are really transforming how we think about our homes. These are mold resistant. It's a mold resistant material. It's a high pH material. It's a breathing system. So instead of the typical building envelope where we're sealing it as tight as possible, we're using all kinds of products to watertight and airtight our structures so they perform to a certain level. And when we say perform, it means that they can be recorded. Because it's all about creating systems. The building industry is being based on systems, wall systems, and other things that can be quantified, which I think is really to the detriment of the industry, because it's not allowed for natural materials to really get in the position that they should be, because it's hard to regulate a natural material. There's a lot of variations that happen in natural materials that are not quantifiable like a lot of these other building materials, but things are shifting, and this material is really resilient in a lot of respects. It's fire resistant, it's pest resistant, mold resistant, as I was saying. It's has a very high insulative value, especially when we use it as a fully encapsulated system. Typically hempcrete is being used in cast in place. Really, it's a non-structural material that comes from the center of the hemp plant, the stalk of the hemp plant, the shiv, which is processed down into small pieces around 1/2 inch or 1 or 2 centimeters, you would say in the metric, and mixed with a hydrated lime, mixed with the binder as well. And essentially this material is not it's not a chemical reaction, it's actually a calcification. So it's wanting to turn back to a stone. And essentially it's a process of petrification. So is a lot of chemical process materials will break down. They have a lifespan. A lot of things in the building industry have 15, 30-year lifespan is classified as a lifetime. 30 years, as we know, isn't very long in the lifespan of a building. So it's really transforming that the idea that this material is calcifying over time. It's actually, it's taking in carbon back into itself as part of a hardening process, a curing process. And it can be used also, it can be sprayed in, it can be used in our wall systems, in our floors, and our roofs. And as you can see here, I know one of these, the picture on the top right there is a home in Australia, I believe. And there's a lot of examples of these homes all around the world, which are really taking on a new form, creating a new type of architecture. And then you get into the interiors of these homes, and it's a really beautiful material. It's not just ecological, it's not only a breathing, healthy system, but it's a really beautiful home. And we've been working with this material for the last few years, and the product, the final product and the experience of these homes is really different than a lot of regular homes. My first hemp home experience was in the mountains of Switzerland, in the snow, minus degrees outside, 3 feet of snow, and we didn't have heat on in the house for 2 weeks, and it was like a fresh air environment. We're walking around shorts and t-shirts. This was like a sea change for me as an architect, as to a building material that could feel like an outdoor environment. And then it can store heat energy in the walls because it has a thermal mass quality to it too. But in the industry right now, there's a lot of issues around architects not really taking on this as a building material with their clients, mostly because of the building code is not up to par. I've been in a process of getting a hemp addition on a house in California through permitting for almost 2 years now. So it's kind of crazy that this building material is not there yet. But what we're trying to do is offer small structures, blueprints for dwellings that are small casitas or an accessory dwelling unit, or maybe a tiny home, something like that, that people can build themselves and maybe don't require permitting. So we have blueprints for sale through Haven Earth Database. You can check them out. We're really trying to help people to be able to work with a design that they can build themselves. On the left, you can see that's the kind of iconic hemp house we built in California in 2019. That was featured on the Discovery Channel. And then another one, we're doing a lot of trainings. So we've been traveling around for the last 2 years doing workshops and trainings and really teaching and developing the interest for clients and for people who are looking to get into this industry right now, because it's a moment in time that this industry can take off. But we really need to be informed and help to inform consumers, and also get the builders excited about it, because this is the wave of the future. And we know they're looking for something else. They're looking to get out of a toxic industry, but they're not quite sure how. So at Haven Earth, we're really focused on the trade school. And then really the other part of this is, how do we create a modular system that's going to fit into the marketplace and replace some of the existing modular systems like concrete blocks and all of these other things. The hemp building blocks are starting to come onto the market in the United States, and that's going to shift the building industry, I think, here. In 2024, we're looking at it being adopted into the residential building code in the United States. So there's going to be a big change in that respect. Here's a commercial project in South Africa, which is, I believe, a hotel project, and it's a structural frame with a CMU, with a hempcrete block infill system, which is for insulation and for health purposes. And here's a little bit more about the trade school. about the workshops and trainings we do and certifying builders in the US. You can check out the havenotradeschool.net, where we have courses on there, we have online programs, and we'll have upcoming workshops. And I just want to share this little video with you all.
Builder and founder of the Havenot Trade School. If you're a builder or contractor looking to pivot into the hemp industry, a student ready to learn, or homeowner looking for a healthy hemp form, this is a course for you. Learn about the benefits of building with hemp and gain a practical understanding of this revolutionary building material that is fast changing the face of construction in the world today. Hemp is a new way of thinking about how we construct our homes. Not only are we getting building materials from the farm, but we're building homes that are natural, fire and pest resistant, and mold free. These structures actually regulate the indoor environment in our homes by exchanging and purifying the very air we breathe, and they can be built in any climate. We have put together a comprehensive course for ecological construction with Hempcrete, including live footage from actual builds, complete with project blueprints and resources to guide you through the process from design to finish. We take you through the entire process and share all the details you'll need to know for building with Hempcrete along the way. After 2.5 decades working as an architect and project manager internationally on projects built with the standard unhealthy toxic materials, I shifted into natural building space in search for answers, and I've discovered the next level of construction through experience in hemp buildings in Europe. What I quickly realized was that there was not a lot of information out there about building with this amazing material, even though they've been working with hemp for over 3 decades in Europe. So in 2018, the same year hemp cultivation was legalized in the United States, I decided to start offering hands-on trainings in hemp construction. And in 2022, I began documenting the process so that I could offer a useful step-by-step course to show all aspects of the building with hemp. And the great thing is that the course is ongoing and interactive. We continue to add content for new builds and host monthly Zooms where you can get your questions answered and meet other hemp builders. So we keep learning, and so do you at your own pace. We'll provide an overview of the course, highlighting the benefits of building with hemp and setting the stage for an exciting learning journey. You get exclusive access to several of my architectural designs for hemp projects valued at over $1,000. If you're here looking at this course, you probably want to do something that you feel good about. You want to make a change, like building healthy hemp homes that are good for people and the planet. I invite you to join us on this transformational journey toward becoming an expert in the field of natural building with hemp. Through detailed instruction, practical demonstrations, and insightful bonus materials, you will gain the knowledge and confidence to create healthy, ecological, and energy-efficient structures in Hempcrete. We'd love for you to join us, so sign up today.
Yay. Well, hopefully that was a good overview in a short space of time. Maybe I went over my time a little bit.
No, brilliant. I'm sure some people might fall a little short, so it's quite good. So thank you. That was bloody awesome. Oh, thank you as well for staying up so late. I really appreciate
No worries.
it. Sorry about that time difference thing.
That's all right.
All right, we'll chat soon on the email.
Anybody have any questions?
Now, oh yes, sorry. Okay, so we've got a little Q&A box as well. If anyone has any questions, just click down on the Q&A and enter your questions. Farid has his hand up.
Hi, Paul. Good afternoon. Thank you so much for this wonderful presentation. I've never heard of using hemp in as a construction material. Just had a quick question about whether it's being used as an isolating panel, being a thermal isolator or soundproofing isolator, or can it actually purpose a structural functionality as well?
Couple of questions. Sound quality is amazing with Hempcrete. It has a really high decibel rating for sound absorption. So it's great for like a recording studio. It's great for a party wall between dwellings. And it's also a fire block as well. It's becoming a big thing in California because of all the fires where they're looking to bring hemp in as a fire-resistant material. It's still not as classified as a structural material. It doesn't have the load-bearing capacity. It does have beneficial strengthening of the frame. So it will strengthen the actual wood frame of a house because it will encapsulate that frame and stop it from breaking, essentially, from snapping.
So we have some high-profile academics like Professor Veena here might be able to get some research done about using this material as a structural element as well, because
the University of Nebraska is actually working on a structural hempcrete formula right now, and their first tests were like incredible. It got so hard that they couldn't break it out of the mixing machines. And yeah, it was actually too hard. But the issue with that is when it becomes structural, do we start losing some of the characteristics of the hempcrete, which is its permeability, its breathability, and if it becomes a structural material, if we lose the benefit of it being able to deal with vapor, moisture, and regulate the indoor environment of our homes, then essentially we just have an alternative to maybe something that's not great, like a concrete block, but it maybe won't have many of the benefits that I think are really relevant for the shift to a healthy home building industry.
Definitely.
So that's something we got to look at. I think kind of creating panel systems with some kind of web structure frame that would minimize the use of any lumber would be really the way I would go with it.
Nice.
Thanks for the question.
Yeah, very good question there. Let me just add spotlight. Hello. Now I've got to, how do I get you off there? Here we go. Remove spotlight. Okay. We also have one more question here from Luca saying, is it applicable to apartment developments? Is the first question. Would you like me to hit you with all four questions? No, it's probably easier if I do one by one for you now. So is it applicable to apartment developments? Yeah,
I mean, I think as that project in Cape Town was showing that it works great in a hotel environment, and the sound qualities, the fire resistance, and all of that. I think the main thing would probably be around cost efficiencies. Something like an apartment complex, they tend to want to save, but it's a little expensive right now, so that's probably the only thing that would stop it. But apart from that, you could use a reinforced concrete frame like most do, and then just infill it with the hempcrete blocks or cast in place or something like that.
Nice. Awesome. And the next question is it easier to obtain passive house certification?
I don't know if that's an
yeah,
Australia
it might be an Australian thing, or
I'm sure it is, because it does regulate the indoor environment. It requires less cooling systems and heating systems. So essentially it has a more passive nature to it. But that really is going to depend on your climate of where you're building as well. Because if it's really high humidity, then you're going to have to look at doing a thinner wall system, which might make some challenges for the cooling elements of it. So it's like really a balance. I think that's a good thing about this space right now, is that there's a lot of opportunity for innovation to come in, and a lot of people who've got ideas and who want to bring something to the table to kind of innovate something like this.
We have a lot of those thinkers here today, so I'm sure you're going to be reaching a great audience with what you're letting us know about. That also comes into the next question about are the walls thicker than usual wood frame houses?
They can be. Typically they are. Oftentimes in Europe they're going with like a 30 centimeter wall or 12 inches, and then they can encapsulate the wood frame. The hempcrete blocks tend to be about 8 to 10 inches thick. but you know, it does have a high insulative quality, but that really is because of the thickness in some way. Because it's a lighter weight material, you can have a bigger block, and it's not as dense, it's not as heavy. But I personally love that aspect of it, actually, that it is a thicker wall. You know, a lot of the natural building movement, the walls are thicker. You know, you see straw bale homes, things like that. The walls are much thicker, and I think that's an appealing part of the natural building industry. That, you know, when you're just doing a 2x4 framed wall, you really don't have a lot of meat between you and the outside. It kind of feels like just a hollow shell for a lot of respects.
Yeah, it feels a lot more cave-like and cozy, I think, in those type of houses. Yeah,
for sure.
The last question from them was how much easier is it to repair, or is it easier to repair services that run through the hemp walls? I don't know if that makes sense to you.
Yeah, I mean, it's a tricky question in some ways. It depends on the services, I guess. Because it is a somewhat lightweight, you can use woodworking tools to work with the materials. So you can use like a typical skill saw, or something like that, to open up cavities in the walls. I had a project where one of the mixes that was made, it was a workshop, so it was a little challenging to monitor it every time. It wasn't so good, so I had to do a repair. I had to take out a whole section of wall months later, after the structure had fully cured, and that was about a 2 foot by 8 foot section of the wall, and it was right in the middle of the wall. I had to take the whole thing out, and I did that in a day. So it was really, and then the next day I re-hemped that whole area, and it's in perfect condition now. So, you know, you can open it up if you want to add an extra window. You could just cut a window in there. Typically with services, we'd want to be more forward thinking in terms of where we're placing services, so we know where they are, and make sure we don't penetrate any of our services when we're doing the work.
Very good. Great. Oh, we have one more here from somebody else. Manfred has asked, what is the lifespan of a hemp block? Great question.
That's a good question. We'll find out in 100 years, I guess.
Yeah, true. It's only just started, hasn't it?
Yeah, I mean, I know there's structures in India, the thousands of year old cave temples that have hemp lime coatings on the interiors of these ancient caves that are in perfect condition. And really, I think the main point is that it's moisture that gets trapped in our buildings that actually deteriorates the wall systems, because that moisture can't escape, and so it just rots away there. Actually, the creation of hempcrete in Europe was basically for that fact, was that these old masonry and wattle and daub buildings, these old kind of national monuments, let's say, were in disrepair, and they needed fixing. They needed somewhat insulating and kind of held together, and concrete wasn't an option because it would have isolated the moisture that's already in that wall system. But they applied hempcrete over that wall, and it allowed that existing structure to breathe. And so they're using it in repairing these ancient structures. So we know that it's got a long lifespan. Personally, I think if you upkeep hemp building, it doesn't really have a lifespan issue. But it's hard to determine that because we haven't had enough testing so far.
That's it. Time will tell.
Yeah, exactly.
Oh, that's brilliant. Okay, so that's all answered. Questions sorted.
Great.
Thank you so much. And you can finally go to bed now, River. Thank you.
I'm wired, so.
You've just traveled all around the world today, so you know you can go rest now.
Yeah, well, thank you guys, and if you don't mind, I'm going to jump off. But I appreciate you all, and I'll get the recording from you later, Peter.
Lovely. I'm sorry I started it a little late due to the technical bit before.
No, it's all good.
We only
have a good one. Thank you very much, everyone.
Thank you. Bye.
Yeah, just check us out at havenoaktradeschool.net.
Oh, yes. Everybody check out their website and all of their services on there. Brilliant. Thank you again. Bye.
Bye.
Okay, so up next we have the wonderful Mick Fabar here. Hello. Welcome to the spotlight, Mick.
Hello, thank you. Thank you,
All
Beth.
right. I'll give you a little bit of an intro as well so that you can have an intro like everybody else. So give me a moment. Here we go. All right. So Mick Fabar, he's the founder and CEO of Green Home Builders, and with over 25 years experience in the building industry, has been a leader of the green homes from its inception in 2006 through to today, operating in 3 countries, Australia, New Zealand, and the United States of America, offering a truly sustainable option to all customers who are looking to build a new home. Great. Well, I will pass it on over to you, Mick. If you can figure out how to share your screen with the button at the bottom there. When you're ready. Brilliant. Very, very good. All right.
So can you, am I sharing correctly? Is that working?
Yes, we've got you there. If you want to put that particular thing into presentation mode or like a full screen or something, that might.
Is that working? Yep.
Because we can see all the stuff around the edge of the presentation.
Right, okay.
That makes sense.
I'm not
Yeah,
sure,
where's that?
I'm not sure how to do that.
Yeah, nor do I. I'm having a look around with you too. I don't know what happens. No. Usually there's something, isn't there? In the corner. This looks different than the one I'm used to.
Not sure.
Maybe try
Bottom
double
right
click.
corner, it has a presentation thing.
Where is it?
Bottom
Bottom right.
One right. Yep, that's it.
Oh, good. Oh, yay. Very nice. Thank you, Farid.
Thank you.
All right. I'll mute myself and we'll pass it on over to Mick. Here we
Okay, thanks guys. Thanks for the invitation, and happy to have a chat today. Look, as per my introduction, I'm the founder and the current CEO of Green Homes Builders, and we operate in Australia, New Zealand, and the US. We operate under a partnership franchise model, so we've got over 100 builders operating under our brand throughout those countries. And as our name suggests, we specialise in green homes, so homes that are energy efficient, sustainable, healthy, and environmentally friendly. We were a little bit of credibility, I suppose. You know, we've built thousands of green homes, the highest rating homes in Australia, New Zealand, and that's our plan in the US. We've only been on the ground in the US for about 4 years. In January this year, we won one of our projects in Perth, won Global Home of the Year from the National Association of Home Builders in the US. So probably the biggest award that a builder could win, I would think. And this particular home is a show home in Perth, Western Australia, in a warm climate. It's the highest star rated, most efficient 2-story home, freestanding home in Australia. This is a pretty common question that I think is misinterpreted throughout the building industry, but you know, what does it mean to build a green home? I think something that I'm constantly championing is that the industry believes that building a green home or an energy efficient home or a sustainable home is expensive and difficult. And I can say with over 20 years experience that if you understand the principles well, it's not expensive and it's not difficult. It's actually quite simple. So understanding the principles around sustainable design and the best use of products, solar passive design. So we're using the sun to heat the home, such as the picture that's on the screen right now. That home's one of our show homes in Fargo in the USA. So something that was not built in that area. You know, consumers were quite besotted with when it opened only a couple of months ago. We had 626 people through in 4 days through that home. And you know, they just no builder in that particular area had been building to allow the sun to come in. And what's happening here is, as you probably all know, the sun's coming in. This house is south facing. The sun's coming in and heating up the thermal mass in the polished concrete floor there. and we've got well insulated and sealed walls and double glazed windows, and then that home's retaining that heat in a very cold climate. So home's performing well. The wash up of that home was that it was per square foot, which is how they talk in the US. It was within 2% of the standard industry costs, and the energy use of that home was reduced over the last. We've only got 2 quarters of testing, so we don't have a full year of testing, but down by 82%. I think the biggest thing that's happening in our industry at the moment is the impending legislation changes. So here in Australia, we've got code changes that are moving the star rating or the minimum rating for a home's performance, moving that up. It's quite a significant move. The last move we had was from 5 to 6 stars in 2010. We're now moving from 6 to 7 stars, which is a significant move, and a lot of builders' homes just will not perform under that process. But around the world, we're seeing multiple changes in legislation. In America, we're on the board of the advisory board for the Department of Energy. There's a legislation that was introduced federally in August 2022, which really is a decarbonisation movement across the US for new and existing buildings. So over the next 10 to 15 years, the US, in particular in the US, they've raised billions of dollars to support green initiatives and changes to existing buildings and new builds. And those code changes are coming, and they've been just creeping along for some time now. So, but around the world, Australia, or certainly the 3 countries we operate in, Australia, New Zealand, and the US, are all increasing their minimum standard code. For anyone that might be listening, that's thinking about investing, whether you're building a home for yourself or investing in a property, my advice, I'm not an investment specialist, but my advice would be that you invest your money and your resources into a green home. Obviously, investing in property, whether it's a gain for yourself to live in or as an investment vehicle, you've got to think it's a long-term game, and if you're not thinking green now, in 10 years' time, anything that you build today will be well underperforming what those national codes are. So, and my message for anyone that's sleeping on adopting green construction, I think the train's leaving the station. I think, but the train's been leaving the station for some time. So, and how our business model works is something that we never set out to build a partnership franchise global brand, but it just happened really by default. But what we understand is the significant change in the building industry that needs to happen is that the material manufacturers are already there. There's already material manufacturers all around the world that have got efficient and highly sustainable products, from the hempcrete that we just listened to, but all sorts of products that are readily available to consumers and builders. And the code's changing, and there's absolute an abundance of consumers wanting energy efficient, sustainable homes. Like that's, you've only got to do 10 minutes of research, you'll find that that's the case. It's been swinging in that direction for the last 6 or 7 years. The reason why it is not being adopted is because builders need a full business package to build green. It's not that builders don't want to build green, or they need the training is one thing, but they need more than training. We've found they need a business model, they need a brand, they need support with manufacturers, they need support with systems, they need marketing, paraphernalia, PR and templates. They need business management systems that all support the green movement. So for builders, for an individual builder to go off and do, a 4-day green building course, for them to then come back and start building green homes, it takes a lot more than that. So that's where we've found success, is that by packaging up to our knowledge into a business package, business in a box, we call it. It's a global brand, globally certified, systems, processes, relationships with manufacturers and material providers in all 3 countries, marketing, PR, consumer confidence, all of that sort of stuff. We've got very successful franchisees operating in all of those sectors. So, look, that's a little bit about our business, and I suppose that's I'm open to questions and answers. I'm happy to talk about anything that I'm happy to share knowledge. I'm always happy to share knowledge about our experience in this space. So if anyone's got any questions, happy to chat.
Brilliant, brilliant. Let's see. Oh yes, here we go. Farid, let's have you
Always
unmute?
have questions. Thank you so much, Mick. It was fabulous to know
My
that
pleasure.
Australia is moving forward in sustainable development. Just something that pops up is that comparing your presentation with Paul a few minutes ago, so apparently there's a bit of struggle to get certificates in US. Now, since you have experience both working in Australia and US, what sort of differences do you see in terms of regulations here and there?
Yeah, good question. I think certification around new product material or new products and materials might be quite convoluted, and I'm not in that space, but we're building, homes that are 4 or 5 times more efficient just using the standard materials that everyone uses. So I think, interestingly, the big lack in the green building space or the sustainable building space is the builders. We launched the brand at the Atlanta in America. We launched the brand at the Green Build Expo in Atlanta in November 2019, and just some interesting stats on that. 502 exhibitors. The expo was opened by President Obama. 10,000 people at his opening speech. Massive global expo, world platform. 502 exhibitors, 1 builder. Everyone else was a product manufacturer or a code writer or a legislation component. Like, so we had HVAC systems and double glazed windows and bamboo flooring and everything that you could think of. 1 builder, and I'm not even exaggerating.
Well, the knowledge is there, but the application or putting that into
Correct.
practice is a bit of a difficult.
So we've got, if we think about it as a football field, and it's exactly the same in Australia, and this is where we've found success. If we think about it as a football field, at one end of the football field, you've got an abundance of consumers that want energy efficient, healthy homes, and COVID just 10x that whole space. Like, health is now a huge part of that discussion, which it wasn't before COVID, not with us anyway. I mean, it was something important to us, but on the consumer angle, we didn't have consumers saying, I want a healthy home for my, my parents to live in, or my kids to grow up in, or my family. That wasn't part of the discussion. Now it's part of the top 3 components. But in any event, back to the football field analogy, at one end of the football field, we've got an abundance of consumers that want energy efficient homes. That's the whole market. Like, the majority of the market want that. At the other end of the football field, we've got product manufacturers globally and governments that all want energy efficient homes to be built, sustainable, healthy. Every single product manufacturer on the planet today has a sustainable angle, some greater than others. And the only way those 2 things can come together is the builder. The consumers can't buy the products direct from the product partner without the builder engaged, who goes, yes, I can build your home with double glazed windows, or I can build your home, I'm happy to build your home with hempcrete, or I'm happy to build your home with this level of insulation or this level of passive house design, or whatever that may be. The only person that can make it happen is the builder, the quarterback. Game can't be played without it. So that's where we focus our knowledge and support, and our business model is around the builder package.
Thank you so much.
That is, let me bring myself back to the conversation. Hello. Now that is, let me see. There we go. We'll get you off there. All right. Thank you so much for that, Mick. We've got one more question here from Luca, asking, as you've pointed out, builders are lacking the expertise. Would the industrialization of the construction process via prefab help navigate?
I don't believe so. I think prefab and modular construction's got a long way to go. I think that the problem with that type of, if I'm on the same page, the problem with that is that for that to be successful, the whole industry needs to change. So builders and contractors are very used to doing building homes in a certain way, and I know that from my experience, it's the journey of building a home and the process of for a consumer and a builder is exactly the same in America as it is in New Zealand, as it is in Australia. In some locations, the home styles can be different, but the process of building a home is exactly the same. Some of the terminology is different, lumber, timber, siding to cladding, but really the process is mirrored. Where I think, SIP panel systems, modular homes, where I think absolutely they bring a lot of advantages to the market, but the problem with that is that the whole industry needs to change to adopt that. So I don't think builders and contractors are ready yet to adopt that type of construction. So unless it's a developer placing those sort of buildings on site and then selling them done, I think that the industry has been operating the same way for the last 100 years, and changing that is many companies have tried, and you can spend a lot of money and resources on that. Where I think the gap is, I don't think the gaps personally, I don't think the gaps in the industry, builders picking up the knowledge is the gap. I don't think that's the problem. There's, even the training that we've got, we've won some global awards for our training. We've got the same principles. Global green home sustainable building principles are the same globally. Like solar passive design means the same in New York as it means in Auckland, means in Sydney. The application of that principles changes depending on the climate, and that's not overly difficult to work out. Leakage and sealing and all that means the same globally. Again, back to where we founded market is that builders need more than the knowledge. They need more than they need to know more than there's products available, and this is what the green building principles are. They need a whole business package to close down their independent building business on Friday and reopen on the following Monday as a green builder. They need a whole heap of stuff. So that's the space that we fill. I'm quite surprised that we're just the only builders in the world globally that are doing it. There's no other green building scalable model like ours. We've been certified globally, and I genuinely thought that there'd be a heap. We got an opportunity to open in America, and I said, not interested in going over there. I hadn't even been to the country, but I just assumed there'd be, tens of hundreds of green building solutions, scalable business models. We got over there and there was none. The opportunity was too good to refuse. So anyway, that's how I don't see the industry changing, other than you need to give the builders the tools to actually make change. So that's where I think the gap between modular construction is compared to standard construction. I think standard construction is still going to be around for another 50 or 60 years.
Do you think we've actually attracted a really great audience of architects? So I wanted to really, sort of target them as audience members, because do you think that maybe starting at the root of the design process prior to it getting put to a builder, do you think that having more green architects is actually going to inspire more builders to go green, because the plans sort of have that sort of foundation there for them already? Do you think? Yeah,
I think in my experience, there's plenty of green. Obviously, a green home, sustainable home, has to start with a sustainable design. You can't take a standard cookie cutter home and then just increase the efficiencies of that home substantially. You can do that, but really it comes back to getting the design correct. Windows in the right location, the right orientation, and the right shading, and all those things. It's pretty simple stuff. I think that there's been architects banging their heads up against the wall for years and struggling to get builders, after they design these homes, to get builders to adopt and build them. We've got our own internal architect capacity, obviously, but I know that a lot of our builders are seconded by other architects that are building green. They just can't get builders to do it, and it comes back to builders need the knowledge, the training, the product support, the package. They need a business package to go and build green. They won't, otherwise they just put their head down, do what they were doing yesterday. And when we think about the training for builders, the journey that they go on, they do an apprenticeship or a traineeship of sorts, and then they're usually a block of experience, and they get their builder's license and open up building their own building business. And it's the same in Australia, New Zealand, and the US. So I'm talking about all three countries. Nowhere in that training, there is nowhere in that training where they learn sustainability. Nowhere. currently today, that's all optional. If you want to learn about sustainability as a builder, that's something that you have to do on your own. You know, you can go and do multiple courses, but nowhere in their journey usually today is anything significant about sustainability. So we've got some massive gaps in their training. So what I'm saying is we've got builders getting churned out now that in the same process, following the same pathway and the same journey as what we were in the 1950s, the 1940s. Nothing's changed. Obviously, there's technology changes and all sorts of other things, but when we talk about sustainability, it's the same.
They got rid of asbestos, apart from my house.
I mean, we're getting better with toxic materials, and builders are getting safer, I think, globally. But from a sustainability standpoint, there's nothing to promote them. So it's all optional. The problem that builders don't understand, they think it's optional, but actually it is for them. But out in the real world, in the community, consumers, the whole majority wants energy sustainable, energy efficient homes. A quick Google data analysis will show anyone just how big that space is, and it's the main majority of the consumer space in the building industry. It's just an opportunity that builders aren't seeing because they're too limited. So.
Well, they've already got all these people coming at them from both angles. Let's hope that today we're going to shake up a few people, maybe fill a few of the educational gaps that that you've highlighted, because some people are not aware of things until somebody there is to say, hey, it's not being done. So, maybe you'll.
I don't want to be critical of builders. I'm one myself, but I think I think as builders and architects and manufacturers and everyone, and I know obviously I'm talking to a panel of like-minded people, but just generally in the building industry, we have an obligation, I believe, to think about building homes or designing homes that are energy efficient and healthy, instead of just thinking about we need to build a home that is watertight. And that's the big difference. We've got builders that don't even think about energy efficiency, the health within the home, the life cycle of the home, the products that are being used, because it's all too hard. As long as I build the home that meets the code and it doesn't leak, that's all I need to do. And that's the thinking, right? So where the consumer expects a builder to think about all of those other things, and we're just not seeing it. So certainly that's the market we've tapped into. We started in 2006 and it just evolved from there. So
good on you. I appreciate you sort of taking the bull by the horns on that one. Luca has one more question as well come in. So in your opinion, have councils been open to welcoming to green developments?
Yeah, absolutely. There's been, in the last 3 years, I think it's probably it's leapfrogged way ahead of where it was 3 or 4 years ago. 3 or 4 years ago, it was all about just make sure it's the code. Now the codes everywhere are changing to adapt for this stuff. But more than that, I think there's developers. We're in quite a few partnerships with developers in all 3 countries that are, if they're not developing green or they haven't got a green, proof of concept, their developments won't get approved. So I know that I know here in Australia, we're in a joint venture partnership with Mirvac, Australia's biggest developer, right across their whole estates. They're implementing green communities from 2024. So it's not all about volume for those guys. You can still achieve volume by just building green. It's just about changing your considerations and your planning considerations and the design considerations for those estates to allow homes to be more suitable for solar passive design and the blocks to be orientated differently. So my answer to that question is yes, and I'm seeing it everywhere.
Very good. All right. Well, we are now running overtime. You did so good, Mick.
Sorry, guys.
You've done so brilliant. Thank you very much for inspiring everyone with your presentation there. I will bump you out of the spotlight and we're going to welcome Peter Leeson in a moment. I'm just going to give a little introduction about Peter. So Peter Leeson is a renewable energy project developer and building integrated PV specialist with expertise in ground mount solar power civil work, PV design, and power system engineering. As Volt's co-founder and managing director, he has spearheaded the development of the world's most powerful solar tile. Volt's innovative solar tile has gained worldwide recognition with distribution channels spanning 86 countries. Volt is currently in the process of developing a plan for manufacturing in Australia. So once this plan is implemented, Volt will become the only Australia solar tile manufacturer to export its products worldwide. And basically, I should leave him to tell you a little bit about this himself before I take all of the juicy goods there. Okay, so let's put you in the spotlight. Hello, Peter.
Thanks for the introduction, Peter. I appreciate that.
Welcome.
Sorry, I'm just working on sharing my screen. Give me 2 seconds. There we go. Okay, so that was the introduction, and I think probably most of the presentations. I don't need to say too much. Yeah, I'll talk about Volt Solar Tile today, which is a innovative new product. First, I'll just talk a little bit about myself. So I've been in renewables for 16 years, been in the built environment for 24 years. I'm an electrician by trade who has built a business up around solar farm development. So we develop, build, own, operate solar farms here in Australia in some international JVs. We have our C&I and residential solar business, and then we also have Volt Solar Tile, which has been a product under development for about 8 years and was launched in October last year and has now been installed in Europe, Australia. We're about to install the largest solar tile system globally in Turkey, and we're doing UL testing for entry into the US right now. We're launching our first project towards the end of the year. So basically, there's in the built environment, there's a few different options when it comes to solar. You can have standard attached, which will remain pretty standard for flat metal roofs because you can't see the product, so it's the cheapest alternative for renewable energy. You've got facade and windows, so whether it's a curtain wall or it's a solar glass roof or a solar glass window. Very inefficient products, very expensive and low energy generation because of the aspect of the sun. So that you optimize at a 90-degree angle from the sun. It doesn't make a lot of sense because you're going to get low yield, and it's very hard to maintain the product. So being in the industry for so long and also the built environment, we came up with an idea that eventually on a tiled roof or a pitched roof, you're not going to be attaching panels. It's going to be an integrated PV product. So we developed Volt Solar Tile through independently as our own product, but we've done a partnership with Bristol Roofing, part of the Brickworks Group in Australia, and we integrate with 2 of their tiles. So this one here you can see is to their Lodge, which is their flat, or Premier, which is their flat concrete roof tile. And our solar tile integrates just like a standard roof tile. It's just 5 tiles wide. So it just sits there and fixes into the patterns. Basically, our product is the highest performing solar tile worldwide. So we've done a market analysis. We're a 115 watt solar tile with a 19.5% efficiency. The closest competitors sit in about 16.5%. So we've done this through the using really high quality cells and components. But we've also done this through the design of the product, optimizing the footprint of the product. We've made a very wide solar tile, but we've engineered into this a very clever integration system, which I'll touch on in a minute, where the top solar tile locks into the bottom solar tile. So it seals the roof, makes it very windproof. So gets through all the hurricane testing and so on. The product was Australian engineered and designed. So it's made for Australian standard. Australia has one of the, pretty much the hardest PV standard, AS5033 globally, where we have to have HD protection on all our cables. The US has a very strict standard as well, but they're separate. They sit under UL standards. So basically we've designed it for our harsh conditions, our strict compliance and regulations, and we've also designed the product to be very easy to install. So a big barrier to the market for new products, and this is probably something Mick was talking about before, when you're trying to build a green home, it's not so much the design principles It's that they don't know how to do it. So you've got to make it easier to do. And that sounds like what Mick's model is. He teaches builders how to do the entire thing, integrating all those materials and design into a sustainable home. So we've done something very similar where we've designed a product that's very, very easy to install. And we've built a learning management system online so we can train our partners globally to sell, design and install the product. We integrate with the Bristol roofing product, and we also have a strategic partnership with Leeson, a Spanish terracotta roof tile manufacturer that distributes to 86 countries, and we integrate with one of their roof tiles. So instead of something like the Tesla roof, where they've redesigned the entire roofing system and have created this new product that they have to train everyone globally and build new distribution channels, compliance, regulation, licensing, we integrate with the existing roofing system that's installed globally. So we can scale very quickly, through those existing distribution channels. And our durability is really good as well. We have a 30-year performance warranty. So that's pretty much the highest solar panel warranty globally on performance. That's the most that you get out of any module. And we've also got a 15-year product warranty, which is the longest warranty of any solar tile globally as well. So we've met the highest efficiency, the performance and the product warranty. And we've also done a market analysis of the 47 global competitors of solar tiles. And we are the lowest cost solar tile globally installed as a package. So here's just a little bit of footage of a system that we installed in Adelaide in South Australia. That system, it just shows that it's a standard roof / solar tile. I'll wait for it to link back around in the loop. But basically, the footage is just showing how the system interlocks. There's a system that we installed in France in January this year. And so you can see that's on the southern aspect of the roof, and you can see it just integrates. One of our installers just fixing a solar tile in, so it fits like a standard roof tile, except it fits from the back. Very easy to install. The design of the product also has a very strong mullion at the top of it, which means that for an installation perspective, you can actually kneel or put your foot on the top of that solar tile and it won't damage the product. And here you can see that the product's actually just interlocking in. So 2 solar tiles can just lock in together like a standard roof tile. And the next one will, in a minute, will show how it just locks into the watercourse and overall the standard roof tile. So here's the system, again, just showing how our interlock works. We've got a manufacturing business case put together to start manufacturing our product in Australia. It's a 2-stage approach. So the first thing we'll be doing is manufacturing the extrusions in Australia, and we will cut and assemble the product here using a laminate that's made out of our existing manufacturer internationally. The stage 2, that's going to happen next year. The stage 2 of our manufacturing plans is to actually make the solar module here. So there's one other solar module manufacturer in Australia currently, Tindo, who just makes standard solar panels. We will be pretty much the only solar manufacturer capable in the next several years of actually exporting in volume our products internationally, as we've already got the distribution channels and we can compete at the same price due to the complexities of our design. And the extrusions are a big part of the cost of the product, because we need to make an extruded product, 4 different extrusions wrapping around solar cells to meet the same requirements as a molded product, and a roof tile is a molded product. So it's a very complex design, and assembly is very difficult to do unless you're doing it in volume. So we're designing a fully automated manufacturing line to be built in Victoria. Our partnership model is quite interesting. So again, sort of maybe similar to Mick earlier, to scale this product globally, we're not looking to be the installer globally or even the distributor. We're using existing distribution channels. So our strategic partnerships are with Bristol Roofing, part of the Brickworks Group, and Leeson, who are now actually owned by Adilians, one of the largest roof tile manufacturers out of France. And we get our distribution channels through them. So we sell our products to their partners, or we partner with their partners to sign off on the roof. As an example, Bristol Roofing are a roof tile manufacturer in Australia, but they're also a installation contractor. So they install to the big builders. Bristile Roofing install the roof tiles, and our vault partners, they install the solar tiles. So they'll go to the house at the same time as the roofing business. Bristile sign off on the roof. Our solar partners sign off on the solar side of the product. It's bringing the expertise for a roofing business to sell roof tiles, and the expertise of a solar business to sell a solar product, which is super important. So we've got, I think, about 38 vault partners in Australia currently. And we're working with some very large businesses here in Australia as well. Henley Homes has signed up to us, so they'll be installing our product on their display homes and launching on a lot of their roof tile homes that they sell. And then we've also got an innovation working group with Villawood Properties, so they're going to put us into their design guidelines and specify us onto some lots that have been released in Q3 next year. So there's a lot of drive from certain businesses, developers, innovative builders to push renewable products. Our product generates electricity like a standard solar panel, except you can't see it. And that's our real advantage, is that we're not destroying the architecture or the aesthetic of the home, but we're providing it with renewable energy. And there's a QR code if anyone wanted to scan that QR code. It'll give you some downloads and some more information about the product.
All right, so Farid has a question for us.
Hey, Peter, thank you so much. It's brilliant to have an Australian manufacturer of such architecturally unique solar. So I'm not into the market as you are, especially in the solar market, but I remember a few years back, there was a research project promoting use of graphene particles instead of silicon-based solar panels, which would enable generating more, better efficiency in terms of harvesting the solar energy. Is it in the market as of today, or?
No, so we've hit about 26% efficiency. Theoretically, I believe we can get up to about 30, but we'll be looking at Topcom. So that's using a very thin film cell on top of a polysilicon cell. So it's you're going to be adding about 3 or 4% to the cell efficiency. One of the key things to understand, though, is we can keep pushing up efficiency of products, and that's fantastic. But we don't have a footprint issue. We don't have a land area issue. The issues when it comes to energy is cost and firming. So being able to use that electricity when it's required. So the new cell technologies are getting there. Graphene, perchlorates. There's different thin film products. There's Topcon cells. Obviously, PERC are very far advanced. Heterojunction cells. But the key thing to remember is it comes down to cost. So it's about the cost of our energy and reducing that cost of energy so we can make as much of it as possible and control that energy. So controlling devices, charging EVs, controlling our appliances, so on. So our product is more about integrating it into the building fabric of the home. So, at the average size 280 square metre home using our product would install 15 to 20 kilowatts. Now, you don't need that much solar on the home. It could, you could do the same with a standard panel as well. You can put it on every aspect of the home, but it's more about getting that cost of the energy down as much as possible, and where our solution is to also maintain the aesthetic at home.
So much.
Very, very good. We also have just had another couple of questions come in. We've got from Luca, how much easier is it to be repaired in case the tile needs to be removed?
Yeah, great question. It's not necessarily more difficult. It's slightly more difficult than a standard solar panel. The testing process would be that, you would do it as per a standard solar panel array, where you would break it in the middle, and we've designed the system to do as such. So you slide the roof tile up next to each row, break the array, and then do your testing to find out which array you need to remove or which panel you need to remove. But ultimately, then you need to work your way back down the roof to remove the solar tile at the bottom. we've done this on purpose because of our interlocking system. So we don't want, it's got to be fixed, and it's got to be fixed well to the roof, both from a perspective of sealing the roof, but also protecting the home and high winds and uplifts. So slightly more complicated, but in our design and our training, we cover off on that to ensure it's pretty easy to do. But ultimately, at the same time, you don't generally design a system so it that it needs to be removed. You design a system so it can be, but you design it so it's strong and durable for that home. The good thing about our product is if you had an issue or you decide you want to remove it after 30 years, it's a standard roof tile. So you can go and replace it with a roof tile that's been manufactured for the last 30 years.
Yeah. Well, there shouldn't be an issue with it breaking if it can be stood on. It's hurricane proof. I feel like, there shouldn't be much of that being an issue anyway. But yeah, that is awesome. Very good. We have one more question as well from Manfred. We have, what are the disadvantages of solar tiles?
Yep, another great question. So the disadvantage of a solar tile at this point in time is they're more expensive. So they are a premium product. They're not more expensive than your most premium solar panel system. So, for anyone from the solar industry or has done a lot of research into solar panels, that probably understand that, like, sort of your sun power N-phase microinverter system is your most premium system available on the market. That's where you've got an inverter behind each solar module, and you're getting a solar module and inverter system that's got a 25-year wrapped warranty. Our product is the same cost as that fully installed. So it is a premium product. It's not for the first home buyer. It's not for that market. It's designed for, your $500,000 to $600,000 plus home build price, which isn't super expensive. That's pretty standard for your second home buyer. Being that it might be $4,000 or $5,000 more, but that's probably the key critical disadvantage. Another thing, that anytime you integrate a solar cell into the fabric of a building, you will increase the operating temperature of that product. So it retains thermal heat. We've designed our product that we have nothing behind the cells. So basically, a lot of these products in the past have had cable trays or backing sheets, or even being made out of plastic like BMC or SMC with a lot of thermal mass, and that's made those cells really, really hot. And it's done two things: A, it's deteriorated them, but B, heat is the enemy of electricity. So the hotter the cell, the lower the voltage, therefore the current remains the same, the lower the voltage, so therefore the lower the power output. So solar cells have a temperature coefficient, and the hotter they operate, the less power you generate. That's for any solar cells. So our design has specifically addressed that problem. We've found that previous solar solar tiles that we tested have lost up to 18% of their energy. We're only losing about 3 to 4% of our energy from our system.
And they are very sexy tiles, I must say. It makes any roof look absolutely beautiful. The other thing I noticed too is with the usual type ones, they seem to have some kind of a bracket that's raising them off the actual roof, so they're not on, they're not quite an actual part of the fabric like this. So I would imagine that those would also have some kind of deterioration in their brackets as well, which makes yours better as well.
Well, I mean, you've got another part of the system which can, not so much deterioration, but a point of failure. So when you build a new home, or you've got an existing home, the method to put solar panels on is you pull out the roof tiles. If it's a tile roof, it's a metal roof, they just fix down through the battens and the screws. It's a tile roof, you pull the roof tile out, you flip it over, you grind a big channel in the back of it, you put a bracket down, and then you put that roof tile back in, and that's got a gap in there that's not tested or compliant. So basically, not only do you remove the warranty of your roof if it's a new home, but you also, you create a serious issue for water ingress into the roof. And if your sarking's no good, then you'll get water obviously into your ceilings and your structure. And as we saw with the hempcrete presentation, retention of water in homes is the biggest issue of deterioration. So, our product obviously has been done all the dynamic weather tests, wind-driven rain tests, so on, to show that it doesn't leak. We actually outperform the roof tiles themselves in our testing, which was a great result. But we also sort of touch on points of failure. We've developed a very wide solar tile, and we've done that for a number of different reasons. But the first is less points of failure. So if you've got, most solar tiles are about half our wattage, half our size, if not even more. And what that does is it means that you need to have more connections in the roof. You've got more joins, you've got more points of failure. So increasing the width, size of our product has meant that we've needed to put our interlock in. Roofs aren't built perfectly straight. If you've got a 5 mil gap in your roof over a metre, that means out of our solar tile you might have an 8 mil gap at one end. So having our interlock actually ties the bottom of the roof tile or solar tile down and stops it from leaking, stops any wind and rain getting into the roof.
Such a brilliant product. Absolutely blown away by it. That's why I was so happy that you could come and join us today. So, do we have another question here? Okay. Are solar tiles harmful or not? I'm not sure if they mean harmful to the environment or harmful. What do you think might that
Well,
mean?
look, I mean, I'll say straight out no. I mean, the purpose of our product is to generate renewable electricity. No, then the only increase in carbon footprint is that we've got more aluminium in our product than we've got more carbon footprint from manufacturing our product because we've got more aluminium, and aluminium uses a heap of electricity to make, and then also does use gas in the current environment to heat it up to 550 degrees before it's extruded. So, which all solar panels have aluminium, we've just got a small amount more than that. So our carbon footprint isn't a lot more, but that would be the only thing that I could think as a response to that. But ultimately, on the other side of that, we offset roof tiles. So there is an offset cost. So, you talk about when you install a standard roof and solar panels, you've got your roof installed, you've got that weight on the roof, but then you've also got the carbon of those roof tiles and the environmental impact of those roof tiles and the freight, the shipping to the site and the installation. With our product, we actually remove roof tiles from the roof, so they're not required there. So you don't have the carbon footprint from the kilns firing the clay, either it's terracotta roof or the manufacturing and concrete. Roof tiles obviously have a huge environmental impact being concrete. So if you balance out the entire home in the system, would actually probably be less of a carbon footprint than a standard home with roof tiles and solar panels.
As far as like recycled aluminium goes, would that be a product to use that would be then make your product more expensive? Are there sort of ways that they can do that? Because I mean, it seems strange to create a new product that's already being recycled around the place. Aluminium, I suppose, is kind of, I don't know, just a thought.
I mean, look, aluminium is a very easy product to recycle. So, as an example, I was in Australia's largest aluminium extruder yesterday, and we had a look at their plant, and they were showing us how they recycle every single piece of aluminium. That if they've got test pieces, off cuts, so on, faulty parts, they get cut up and sent back to the recycler. It's a very easy product to recycle. So there's not it's the raw material that just gets melted up again and turned back into logs and then goes back into extruders. So look, it's not really an issue where aluminium's not getting recycled. In Australia, though, you talk about solar panel recycling, we're up to 97% of the products recycled, and in the next 3 or 4 years, we'll be up to 100%. And hopefully our government and governments globally start to put a small tariff on solar modules so we can ensure that they're recycled sustainably at the end of life.
Fantastic. What a brilliant presentation, Peter. Very, very impressed with your work. I'm sure everybody else here is as well. So we shall let you head off. Oh dear, I've got cat meowing. Wait. Well, thank you very much for joining us, Peter. And next up we have okay, we've got Professor Veena Sahajwalla. Okay, so I'm not sure. Here she is. Do you have any of your colleagues with you as well today?
Yep.
Awesome.
Anirban's online as well, so we'll just do it as a joint presentation.
All right.
Peter, and there's
Okay.
Anirban as well joining in. So yeah,
Excellent. I will put you both in the spotlight then. Let's see. Add spotlight. Aha, there we go. Okay. Now, oh yes, first I was about to, one moment. I was just about to welcome you first because everybody else got such a wonderful introduction and yours is fantastic. So Professor Veena Sahajwalla is an internationally recognized materials scientist, engineer, and inventor, revolutionizing recycling science. She's renowned for pioneering the high temperature transformation of waste in the production of a new generation of green materials at the UNSW, the New South Wales University, Sustainable Materials Research and Technology Centre, which she's actually the founding director of. We shall leave you to talk about the rest yourself because otherwise, again, I'm going to take away all of the goodies.
that's all right. That's all right. Not a problem. I will also introduce my colleague who's joining me online. So Anirban Ghosh is the head of microfactories at Smart Center at UNSW. As we'll unpack over the next 15-20 minutes or so, some of the work we've been doing at Smart around green ceramics and talking about, sustainability when it comes to bringing in more and more recycled content and, of course, remanufacturing. So we'll get right into it. Peter, how much time do we have to?
We're already running over anyway, but let's try and do the 15-minute presentation and then we'll quickly ask some questions after that as well. I'm sure there'll be a few. It's very exciting work.
No, thank you. Well, we might take a slightly different approach towards our presentation. We do it as a joint discussion, if I may, just so that we can keep this as a fairly sort of free-flowing conversation between my colleague and I, and we might tell you a little bit about what we do at the Smart Center at UNSW, but also talk a little bit about different kinds of products that we've been developing. Green ceramics is one example, green steel, another example that, of course, you mentioned as well in your introduction. But let me start with, my colleague and the work that he has been doing and get him to also tell us a little bit about green ceramics. And perhaps we can start with the absolute hot off the press implementations that have been taking place more recently, because of course, as we've been hearing, of course, from various speakers, there are challenges that are multifaceted. It's not just about the development, the science, engineering, but it's also equally important around where the market pull is and really what does it mean ultimately in terms of delivery of products into where the applications demand those and what kind of properties of products you need to be able to make them competitive from not only, of course, the scientific point of view, but also from an engineering and an application perspective. So I might start on that note and perhaps get Anirban to describe a little bit around green ceramics, what they're made of, but also equally important to give you a bit of a sense of where these products are being deployed in Australia and beyond. So Anirban, maybe I'll get you to, for the benefit of those who might not know about green ceramics, give us a bit of a context there, please.
Sure. No, thanks, Veena. Look, green ceramics for us were a solution to waste glass and textile recycling. So a couple of years back, when we started to look at problematic waste materials, and be it at the center, we get some of the most exciting materials just coming in the form of waste that we get to tackle. Waste glass was one of those materials, and from a construction perspective, you can imagine that if you've got glass with a tint attached to it, or if you've got some laminates or safety glass, or glasses that can't necessarily be recycled back into more glass, we were looking for the next set of solutions in that space. And that's where one of the technologies that we've developed in that space has been around green ceramics, where we're taking the properties that are present in glass, be it the hardness, the stability, the ability to have the abrasion resistance, to have something that can give you the properties, but also create engineered products that then, from a microstructure perspective, and when Veena's mentioning the science, also looking at the morphology of those particles so that they don't lead to other health impacts. So we can really bring, the full systems thinking to the equation. We started to combine that with waste textiles, which kind of sounds a bit funky that, why would you mix textiles with waste glass? But the idea there was really to bring in the attributes that waste textiles brings, and that to give us a building product that can be formed. And I think a couple of other speakers have also mentioned something that people may already be able to accept in their current manufacturing processes or in their installation. So it's not pushing the construction envelope into some exotic new material that they've got to bring in, new adhesives or new ways of manufacturing, but it's a like-for-like replacement. However, the idea for us was to make something that's more fit for purpose. So be it made from local waste materials, or meeting a better slip rating, bringing in some of the fire ratings into the product, and meeting those Australian standards that I guess set us apart in building those really high quality products. So in that space, over the last few years, we've gone from our microfactory in our basement, which was doing about a square meter an hour, to a facility that can now do a square meter every minute of this product down in one of our regional centers. And I'm sure Veena will unpack a bit of thinking around microfactories. But the latest installations, we've actually now started exporting as well from Australia, which is kind of ironic that there's a material that's made out of waste that's being now sent as a pilot to a few locations like Florida that has recently had an installation. But for us, it's really those local installs, be it in end of trip facilities or a community center or a library that have really started to bring not only the story of the different waste materials together, but giving us an opportunity to start to scale this technology. But yeah, Mike.
Awesome. Thanks, Anirban. I thought I might, before we progress too further down, is hold up some of these examples, these prototypes that we have. So I'll start to show, and maybe Anirban can reflect a little bit on what these products, in terms of the aesthetics and the colors. You can see all the brilliant and the beautiful colors that you're getting with these green ceramic tiles. And I know, Anirban, you mentioned a little bit around the presence of waste textiles as part of the solution. From our perspective, of course, when we talk about these different kinds of materials and we put them back into, as you were saying, microfactory solutions, and you briefly alluded to the fact that they are, of course, fit for purpose. Ultimately, of course, can you give us a sense where, in terms of the installations that you've been talking about, in specific applications, whether they've gone into flooring, as an example of an installation as to how this has actually been fit for purpose, and of course the fact that you've also got the aesthetics covered there as well. So the fact that you've got all these different colors, but perhaps you can sort of explain the role that you've got, of course, an opportunity to bring waste into a whole new level in terms of performance. And of course, from an engineering perspective, again, you were alluding to a little bit about performance. And that's an important part. It's not just about waste and using waste as from a recycling perspective, but also from an engineering point of view, that you're achieving the kinds of outcomes. So perhaps if you can reflect on that this is ultimately got to fulfill engineering and performance expectations.
Yeah, look, it's a big question in terms of the product, but what we've been so if I was to start with green ceramics, what we've been developing is a technology that has allowed us to make a range of different products. So be it, as Veena was mentioning, a floor tile or splashbacks or wall tiles, even pendant lights, for instance, that have gone into a recent apartment that we that we did a couple of years ago with Mervac as a pilot. So to bring that forward, when we've gone through our gamut of testing and that product development, there has been an element of the aesthetics, which of course, once designers start getting involved with scientists, it's an exciting journey to go down for us, where you start getting feedback, for instance, that the product needs to be a little bit warmer or cooler, or can it look like a terrazzo? And yeah, and you're really kind of going, well, have you seen what we've started to work with? We're starting with a pile of mattress waste, or shredded textiles, which might be out in a little, well, quite a large pile out in the outskirts of Sydney. So to bring kind of that element of that and that challenging waste, and then to convert that into these aesthetic products, but then to also meet some of those elements, as you're mentioning, the fit for purpose aspect goes right from the material to the product development to the manufacturing process. So that each of those steps from a sustainability lens, and that the science and the engineering, the development that we've done, and it has had tears through it. So the first, from a material perspective, it was really understanding how do we make a product that can take advantage of both waste materials and sorry, I think, is that a comment that's coming through? Oh, okay. Sorry, that's the
Sorry, that was just me.
All good. Sorry, I thought there was a question. I was like, great, maybe I can divert some of
I'll get the
questions from
in.
Veena. I was not expecting to get interviewed today. I thought it was supposed to be so I might have to return fire with a few questions. But
yeah, right.
And that's where. But if I was to go back to some of those textiles and really understanding some of those waste materials that are going to, actually, there's the apartment that we did with Mervac. So you can see as a visual the island bench face, the tabletop, the splashback, the pendant lights, the floor tiles are all actually made from this green ceramic technology. And you can see that they bring all these different aesthetics into it, but each of those waste materials as well is unique in the mix. And what we were trying to demonstrate here is that we can create a repeatable product that meets Australian standards, but from a variable feedstock. And I think that's quite an exciting part of the microfactories, where you might have waste glass chemistries change, the mixtures of contamination or the additives that are going in there change. From a textile perspective, we only have to look around our lives to see the diversity in textile. You might have polyester and a cotton, or you might have some coatings to it. You have different colors. And that's where we're able to take all of that and incorporate that into a solution. So from a recycling perspective, if you can imagine, if we were to go to some of these councils and some of our industry partners and tell them, you need to separate every bit of polyester cotton that's got a 60-40 blend and keep that separate. And you've got to keep each of the bits that have got nylon separate. It would be a very challenging stream for them when you see these kinds of bulk waste collections and the way that our waste systems work currently. So for us to come up with a holistic solution where, if we're even looking at, for instance, a tile like this, which is, yes, it's blue and it's got features on the back that make it easy to install, but also from a manufacturing perspective, there's a lot less wastage in the process because it's a molded product. So there's there's minimal wastage in that entire manufacturing process, but there's also minimal breakage, because this product, I think it goes back to the builders, where I think the first time when we had that bit of feedback where he looked at the tile and we told him, it's got waste glass and textile, and he goes, yeah, right, like that's not possible. And of course, the first thing he does as a builder is to drop the tile off the back of his ute, and the tile bounced. It didn't break, and he just went, right, how do I invest? how do I get into this? And I think it's that kind of feedback and that development that really has given us the I guess the excitement to take it to those larger markets. But yeah, I mean, in terms of some of that scientific journey, maybe you might want to go through a bit of that, considering it's been a long journey.
Yeah, look, absolutely. I think this is exactly the point, isn't it? When we talk about innovation, and particularly when we want to start to build capacity here in Australia, we have to be able to bring that journey in partnership with industry. And so for us to be able to do the science is what we call micro-recycling science. And the reason why we do that, of course, as you've probably been gathering from everything we've been saying, we look at really down at the micro level in these materials. So the fact that you might have waste glass, waste textiles coming together in a form of a highly engineered product that we've been showing you the applications, you've got to be able to then, understand how these materials are behaving, and not see it as, a broken piece of glass or, waste textile that is now no longer wearable, but rather see these right down at the micro level where you've got, important elements coming together and creating a whole new structure. So the fact that that manufacturing process has to also take into consideration what that feedstock is. So the fact that in this case, we've got feedstock of waste glass and waste textiles, of course, allows us to then, bring all of these solutions into of course, the marketplace. So from that context, of course, one of the things that I'm sure, Anirban, you'd probably like to share a little bit of this journey around what we've been doing with the manufacturing space of looking at what has actually happened over the last many years. Perhaps if you want to talk about how different product opportunities are constantly being developed, but also equally importantly, as we've alluded to the fact that whether it goes into any product opportunities, the critical sort of focus of our microfactories always has been to be able to have these kinds of decentralized manufacturing capacities so that local supply chains of waste glass, waste textiles. So the whole ethos of microfactories has been very much around, what can we do in the local regional setting? And no matter where you are in Australia, and of course, indeed taking this out to the world, we can actually source local materials. But the important part, of course, is ultimately that important question, are these products fit for purpose? Are we creating local jobs, for instance? So lowering our carbon footprint really comes from the fact that we can recycle, remanufacture, and be extremely efficient in the way, manufacturing takes place. But I might throw the question back at you, Anirban, if you wouldn't mind just kind of taking, I guess, us through what some of these, diversity of products we're looking at, zooming in on each of them, please.
So I guess over the years, the way that the product is developed, and because we started from the scientific end, there was a lot of development in the engineering and the understanding of the waste and what can be converted into and what kind of properties can it meet. And you can imagine that when you're ideating around resolving a waste challenge, the end product that we had in mind wasn't necessarily fully resolved right at the beginning. We knew we had to get to a product to make sure that there was a circular economy or an economic pathway for these waste materials. And we knew we had a vision for what a sustainable business might look like. But that actual product was only really developed through experimentation and feedback from end users and people just even walking through the center going, oh, that looks cool. How did you guys do that? Can I have one of those? And there's a reason that the middle coffee table is not in my office anymore. It's just drawing way too much attention, and people kept wanting to have a tabletop that looked exactly like that. And we have no idea how we actually made it in the first place, because it was one of our first prototypes, and it was a happy accident that we actually managed to manufacture it. But that was local waste glass materials with school uniforms that we'd combined together. And we were just trying to scale it to see how big could we make an object. And being engineers, we weren't super inventive about what shapes we could go for. So we went with a circle and a square. So you'll notice that a lot of our products are of that form factor or variations of that. But it was really to bring it back to how we can then manufacture a repeatable product and to prove the technology. And the partner's logo in the top left there, Kandui Technologies, they're the ones who have taken on that mantle of commercializing this technology and taking it around the world. We were actually just up in Singapore 2 weeks ago presenting this technology to the International Greek Building Conference. And the engagement that we had there as well, people were really excited. They're going, so what's in this product? So like in the top right, it's a mix of school uniforms from Hunters Hill Council. The green there is from ambulance uniforms. The bottom left So we didn't do the nice timber piece, but the wall behind it with the LEDs to kind of arguably we would have probably just made a flat wall, but the designer said no, it needs to pop a bit, it needs to have some design in it. So that that's actually one of those very I guess it's one of those products that for us we always try and bring a bit of the things that we enjoy into some of these waste materials. So I'm sure that Veena has her coffee cup next to her to keep her power through a Saturday afternoon. There we go. So it's every one of our projects will have a touch of coffee somewhere. And in this product, that it actually uses the waste bags that are used to transport coffee beans. And that's how we got that kind of marbling texture and that kind of aesthetic into it. But it's the fundamental material there is, again, that waste glass and waste textile mix that we were using to create those different finishes. So each of the materials for us so far has had a very close story, which I think has helped with the end customers also having a connection with what's going into their products, where it's not just something they're buying off the shelf that they're going, oh, great, we just have another concrete look tile. But that concrete waste, for instance, if we're using a concrete looking tile, is actually coming from either their demo or from a local supplier or from something that they're personally connected with. And at this point, we've been able to work at that scale, but very quickly we're finding that people are now coming to us going, look, we need 100 square meters or we need 1,000 square meters of product. And do you have the waste already? We will be able to supply a little bit, but we can't supply the whole lot. And we're going, great, that's fantastic. But at the same time, we've got people coming to us with tons of the waste material going, we don't need that many tiles. Do you have an end market? And the two are now starting to really line up. I think someone else was mentioning the last few years, the conversation has shifted from being one where we're trying to push sustainability to a point where customers are coming and pulling sustainability. And that's really where that transition in the last few years, we've really felt that as well, where customers are now going, we'd love a decentralized solution for waste materials. And you're like, wonder where we've heard that before.
That's fantastic, Anirban. It's a great way to kind of really wrap up our conversation. And Peter, in the interest of time, I might just leave it at that. We wanted to give you a really high-level description of where we are at the Smart Center at UNSW. Certainly, we're really wanting to acknowledge the fact that over many, many years, as we've mentioned, our industry partners, the research, of course, being supported by them, as well as, of course, government funds to do the fundamental science, develop technologies, and, more recently, of course, taking it further into various commercialization and translational activities, funded as part of our Trailblazer program as well. So, as part of all of this, as you can probably imagine, the journey that Anirban's had so far in leading up to this point as head of microfactories, I think we're both holding our breath, always talking about that whole exponential growth, which has in a way taken place, is really nice to see. I think it's all credit to, consumers in Australia who are really looking for something sustainable, but also love the fact that this is Australian science, Australian technology, being manufactured in regional areas in Australia. So wanted to leave it at that. Thank you so much. Thanks for having us.
We could chat to you all day. You are wonderful. We do have just a couple of very quick questions, even though we're running behind time, but we just want to know, is there, do any of these products emit VOCs, especially if cut? And that relates to another question asking if you can measure the VOCs coming from green ceramics, given the variability of the source waste. And then we have one more after that. So if we can get through those kind of quickly.
I'll let Anirban take.
Look, short answer with emission of VOCs in the cutting process and during install and after install, there are no VOCs in that. It's something that we have done a long series of testing to ensure that it is fit for indoor use. Also, in fact, we've also done analysis on the dust to ensure that there's no crystalline silica being released in the product when it is being cut. So there's layers of that, but a lot of that information is also available now through Kandui's website in terms of that level of testing and the correct use for the product as well. and the adhesives and glues to ensure that it meets those requirements.
So we're hitting manufacturing, or are people able to get their hands on this product at the moment or soon?
Yes, they can get their hands on this product. Again, the order forms are through, so it's through Kandui's website. So Kandui. Yep, their website does take
Kandui. Is that what you said?
Kandui. Yeah.
We can probably put a link in the chat there if you'd like, but that way people can access the website and get to the products.
So good. And the one last very quick question was, are you able to share some specs of the engineering sort of specs about its permeability, flexure strength, and specific gravity, etc.?
Cool. All right. So look, in terms of the flexural strength, we sit between anywhere between 24 MPa all the way up to 64, depending on the application that we're aiming for. So with each of these, and as we're saying, it's a technology, so we can modify the parameters for the product depending on what application is going into. Like obviously, if it's for a wall tile, you don't need the same flexural strength, but you do need a different fire rating. Whereas if you're going for a countertop, we can go all the way to that 64, about 64 to 70 MPa for flexural strength. In terms of specific gravity, we're looking at about 2.1 as a SG. And sorry, what was the last one, Peter?
What was that?
You want to comment on generally? I guess for a lot of these details are there on.
Yeah, there's a tech spec sheet available
on the website, isn't it? So because we may not get through all the details. Now, in the interest of time, that might be a lot faster.
We could certainly talk to you all day, but I appreciate you helping us get back on track. So thank you. And have a lovely day enjoying the rest of the webinar if you're able to stick around at all. And we thank you very much for your time and being here. It's been absolutely very exciting.
Thank you for having us.
Thank you both. Bye. Okay, so up next we have Isaac Akomea-Frimpong. So he is hopefully up here. Has he disappeared? I'm not seeing him at the moment. So we're going to go to Farid. You're actually up next. If you would like. Here we go.
Thank you so much.
There we go. So I'll keep an eye out for Isaac, but at the moment he doesn't seem to be in the house. Here we go. Okay. Take it away, Farid from IconSmart.
Thank you so much, Peter, for organizing this webinar. It's an absolute pleasure to have such wonderful people amongst us. Farid, my name is representing as a research associate from the Institute of Construction Materials. And during the past few years, we've been focusing on a new type of environmental chemical admixture, being able to absorb CO2 as part of its manufacturing or production process. There's a bit of a confidentiality notice here as well. We're not going to disclose any sensitive material here because some of our industry partners are in the middle of the production, being the secret source of McDonald's. You have to be careful about what sort of details we are disclosing. Our topics of discussion today are a bit of a background knowledge, the sources of CO2 gas, especially in Australia, like where we can find CO2, how do we source the CO2 gas, and what capturing methods are available currently, and also at last about multiple types of reducing CO2 emission in the midst of manufacturing or producing construction, typical conventional construction materials, especially in concrete products. I'll try to cut my presentation short to enable other presenters present their outstanding achievements. As for the background knowledge, CO2 in concrete was a topic that's been introduced, if I'm not wrong, more than 20 years ago. Physical entrap is the most basic approach to absorb or capture CO2 in concrete, applicable in recycled concrete materials, and it's targeting recycled aggregate. So what happens in the physical entrap as the approach to capture CO2 in concrete products is that CO2 is being pressurized in the chamber at the presence of recycled aggregates. And the claim is that recycled aggregates will start absorbing CO2 by mineralizing the carbon and oxygen molecules into some different sort of molecules, which eventually makes CO2 gas as a harmful green gas disappear. The chemical decomposition, however, which is the most recent technology, I guess if I'm not wrong, one of these companies in the United States has started commercializing this approach as part of the CO2 concrete project. Is applicable in all types of concrete, meaning that you won't need recycled aggregate as a necessity in concrete. High absorption rate, meaning that you can get higher, like more kilograms of CO2 absorbed by this approach than the physical entrap, and the low cost of production compared to the physical entrap, because the technology is more advanced than the physical approach, highly workable as well. So when we are comparing these two types of concrete, the slump that is obtained from the chemical decomposition approach is much better than the slump or the low of the concrete when it's compared to the physical entrap. The sources of CO2 gas in Australia are mainly turns back to the coal, natural gas, and other types of energies that are being produced. So in Australia, we are having power plants that are generating electricity out of coal by a percentage of 60 to 70%, much higher than any way of generating electricity or energy in Australia. So that's where we are going to target or source our CO2 gas. A typical coal power plant looks like this. We have the input of coal into a boiler that boils the water and takes the steam to the turbines. The turbines start rotating and generate the electricity. In the midst of this process, there is something called flue gas, or these harmful non-environmental gases that are being produced in the midst of generating electricity out of coal. It's called flue gas. So we are going to get flue gas and process it somehow by these three methods: pre-combustion, post-combustion, and oxy-fuel combustion, and extract the CO2 out of them, put them back into concrete, and mineralize them, mineralize the CO2 gas. The pre-combustion carbon capture is this technology that enables the introduction of oxygen and coal into something called a gasifier. Once the gasifier generates the CO2 and water, then the steam goes inside this shift reactor, and that shift reactor will generate CO2 and hydrogen separately for us. From there, we can entrap the CO2. And remember, these are all happening in a coal power plant. Post-combustion carbon capture, which is our main area of focus, is where fuel and air goes into a boiler. The flue gas, which is 15% CO2, is being absorbed by amine absorbents. So we have monoethanolamine. It's a bit of a chemistry or chemical background, or hot potassium carbonate, or chilled ammonia ionic liquids, and other sort of techniques to absorb that CO2. But we take monoethanolamine or diethanolamine to absorb the CO2, and then we can mix it with some sort of a concrete chemical admixture to obtain a high performing CO2 concrete. So the other method is oxy-fuel combustion carbon capture. It's not like this project was introduced and it remained as a concept, as far as I know, 10 years ago. Was funded by Cyro, but it's never been continued because it's been claimed that it's so expensive and the industry was a bit hesitant to uptake this technology. CO2 capture from cement production is another alternative to think about. You can't just focus on the coal power plants. We have other cement plants that are generating way high, larger amounts of CO2 than coal power plants. And so we may have to think about cement production or cement plants as well. So far, we know how to find and source our CO2 that is needed to be converted into some other chemical forms rather than being released into the atmosphere, causing global warming and other harmful effects. Now, the question is, how can we use CO2 in concrete? So now we know how to source the CO2, but in practice, how are we going to use that CO2? The most basic approach is to have recycled layer, and recycling is the most well-known approach to reduce any carbon footprint of construction materials. In the study, the disadvantage of using recycled aggregate in concrete is the low workability and low compressive strength obtained by mixing concrete with recycled aggregate. There's something called geopolymer concrete without cement, in other words. So we're replacing cement by fly ash and slag, plus something called activator, which is normally sodium hydroxide, and cement, like a concrete block is made without having cement. So by replacing cement with fly ash and slag, which are waste materials from other industries, we can reduce the carbon footprint of concrete. Conceptual CO2 gas injector for this chemical approach looks like something like this: a CO2 inlet, and we have mineralized CO2 rich admix as an output. What we have to monitor is the temperature and the pressure. Because of thermodynamics, these two variables can change the properties of the new concrete chemical admixture, in meaning that how much CO2 can be absorbed in this admixture and how much cannot be absorbed in this admixture as well. The main elements of this reactor will be pressure chamber, the shell of this chamber, a gas injector to spray the CO2 gas into the mix, a mixing blade, pressure gauge, and a thermometer. So yeah, that was my presentation. If there are any questions, I'll be more than happy to answer. Otherwise, I'll pass this on to Peter.
I'm just trying to find my way back here. I think you need to end the presentation before I can return. There we go. I should be able to get back in now, hopefully. What's going on? Can I get back in? Oh yeah, sorry. Start video, sorry. I was trying to figure out how to get back in. I'm like, I can't add to the spotlight. Sorry, okay, here we go. Hi, I'm back. Okay, so anybody have any questions about that one? We've got Q&A, here we go. Okay. Is there any ready use for commercialization of this product?
This Carbon Q is a company name commercializing this product just recently in the United States. I'm not sure how far they've gone into the commercialization, but I'm pretty sure a few other Australian manufacturers are also interested in this concept as well.
And it says, yes, our concrete slabs one day available. I'm assuming that's what you were just saying.
Yep, yes and no, because it's not only the admixture that determines if a concrete slab will be available in one day or not. That's the cement type being used, where it will be a high ADS strength cement or other sort of cement. But yeah, it can be available in one day.
Very good, very good. Well, thank you so much, Farid. That was absolutely awesome. Up next, who do we have? We have our friend. Where are we? Sorry. Okay, next we have Nakkeeran Ganasen. Let's just cue you up. If you could, do we have your video there, Nakkeeran?
Hi, Professor.
Oh, there you are. Okay, let's put you in
Actually,
the spotlight.
I'm using this two things because one is not working in my speaker, so I can't do tab also. So I'm going to do these two connections.
It's hard to hear. Sorry, what was that?
Actually, my laptop has some issues, so I can't do both two devices.
Got
Sorry
you. Got you. All right. Well, would you be able to give your presentation
Yeah.
a moment? Okay. All right. I'll pass it on over to you.
Actually, you get mute. Also, get mute. Hello.
Sorry. Yeah, I'm not sorry. I can mute myself now, but we can hear you.
Yeah. Again, I started my presentation. Shall I start my presentation now? Shall I start my presentation now? Yeah. Sure.
Yep, you do your presentation now. Take it away. Here we go. Thank you,
Yeah,
Nakkeeran.
sure, sure. Hi to everyone. I'm Nakkeeran, the researcher from India. I'm from working in a Saram Institute, Katangartu, Tamil Nadu in India. First of all, I want to thank about the 6th International Webinars of Construction Material team members who invite me for the webinars to present over here. Just I'm talking about which I'm working in this research field and as low-cost building materials and biobricks, which made up for low-cost buildings, things who work for a poverty below poverty line peoples. Actually, we work done for this local availability materials also for biobricks. This is my topic which I'm going to present in a few minutes, the development of biobricks using an agriculture waste. These are the topics which I have put in this PPT, and why we need to go for the low cost building materials and alternative materials means we already everyone knows that building materials needs alternative because of this high demand of natural waste and alternative materials because for this low cost, lightweight and those things. So we plan for this low cost materials for the alternative material. We find out the agriculture waste is dumped highly in this developing country and developed countries also. Especially we worked in India, so we consider in India. The India is mostly agriculture based country, so we choose that agriculture waste to implement in the construction materials for replacing a fine aggregate and a post aggregate. But we finally choose as a fine aggregate for the best choice for the brick. It is a low cost materials. When these are the sample examples of agriculture waste we're getting in India, and if we get it disposed without reusing that, we definitely face the waste management and water pollution and air pollutions and etc. and those things. If maybe it may be possible to use in a low-cost material in the buildings. Maybe we can make good sustainable materials, and waste management also we can solve that, and natural resource we can use on low building cost materials, and many things we can achieve by this waste materials. We done small literature on those things. This is a general things we everyone will do for this research work we done before. We get to know that the many papers are published in this agriculture waste by using as a ash as a cement replacement, thermal properties for this panel boards and those things and all. But the very limited researchers are working in this the raw agriculture waste used in this construction industry. Especially why I prefer the raw materials in the construction industry means while using the raw materials, we can easily dispose these materials when we demolish in construction. It won't affect the society much. So the most of the materials are saturated and done the research in this construction industry, like sugarcane ash and rices, wheates, the many things we are using in this wood waste and many things we are using. The most probably the very less researches are done in this groundnut shell. Why we prefer the groundnut shell as a groundnut shell is having a very low density, and most of the people are never touched the groundnut shell using a raw materials in the construction industry. So we prefer it as a low cost materials and low density material in the construction industry for the good sustainable materials for the replacement of fine aggregate. These are the literature basic we are done in this research. We found that the very less number of researchers are done in this construction. We found that the very less literatures of done in this construction industry in this groundnut shell to replacing a fine aggregate or post aggregate, whatever it is. It used in the panel to making a panels for the thermal properties, but we just tried in a different way of using a replacement of fine aggregate because it is a lightweight and low density materials with a high strength materials. If we use in this before the literature says that it is only used in this PCM board and fine aggregate for the PCM boards. It's not used in the concrete or bio bricks and those things. We just small tried with this. These are the availability of this agriculture waste and the globally and in India. The globally it is highly polluted by this disposing in agriculture waste, especially in the groundnut shell. And India also is facing the same issue. So we tried in a different way the fine aggregates. These are the materials which I used for my low cost materials and bio bricks. I used a 10% very less amount of the cement and the recycle amount of fly ash, lime, and the GNS and the sand, which I used the sand is very less as a 10% of the total brick I used as a sand, and 30 to 40% of replaced by this GNS material. These are the test code before which I found this Indian test code IS codes for every testers. This is a basic. First, we collected the GNS materials and we need to grind it because the size particle is very big. So when you're using in this, we cannot compress easily when you are making a compression bricks. So first, we need to grind the materials because the fine aggregate will be very fine. Based on that, we grind the materials by using this machines. By using this miller machines, it rotates for this 10 minutes and we stopped it, and we again rotate for the 10 minutes and we stopped it, and we see and we get this fine aggregate truly as a fine particles to replace the fine aggregate in the brick as a waste material. This are 4 types of materials we get while pass through the sieve analysis. It is almost related to it is almost like fine will be equal to the sand. So we prefer like this kind of 4 materials we used in this concrete bricks. These are the physical and chemical properties which I choose this GNS materials I conducted in the lab, and it is getting too much of cellulose. If we using a cellulose material in the construction industry, maybe giving a too much of thermal properties, and it is like a lightweight, low density, and we can use in this like easily available materials, which and those things we can achieve in this GNS materials. These are the mixed combinations we prefer. And while using this GNS materials, it is a little bit porous. So we plan to use grind properly and mixing in this kind of missions. And we properly grind mixing of this mixtures of 4 materials, the fly ash and hydrated lime and the GNS. While using the grind, this ones, we reduce the too much of pores in this brick. After that, we converted into, we make in the compression machines. It is like the filling of materials, and we compress the bricks. While you're compressing your bricks, it is perfectly coming in a product. When using this agriculture waste, the most of the people are using in concrete mixing and getting into this, getting a very less amount of strength and those things. It is while using this type of process and making a brick, its cost is very less also, and we are achieving this many kind of things like using a waste and low cost building materials and everything we achieve. We casted the plant like 500 bricks on a base things. After that, we have done the results of the density. While increasing a density, while increasing a dry density, the decreasing a strength, and while increasing a dry density, the water absorption also increased. So we plan to stop in this one optimizations is the GNS replaces 30% of fine aggregate in this sand. The brick is totally made with the only waste material like fly ash, hydrated lime, and the GNS, the 10% of cement and 10% of sand, the natural aggregates. So the cost of the material is very less. Like while preparing a material, the total process is like 8 rupees per single bricks. These are the same images we get from this. It shows that the bonding between the GNS and this fly ash and hydrated lime is so perfect, and the porous is very less. This is the specification of the bricks. We achieve the everything like durability, weight, and the less porous and the less water absorption. The thermal conductivity is so good. It is so bonding with the smarter. Everything will be achieved in this one. While using this lightweight bricks and the bio bricks, we getting a high strength and low weight and environmental friendly. We can use this in any climate. The materials are available in local availabilities. We can replace as the wood materials or whatever it is, wood construction and whatever it is. The simple we construct for us a temporary construction. We construct this one is a very low cost and demolished and easily disposed in this society. It won't affect that. It may reduce the CO2 emission of this. CO2 emission of the disposal of construction waste, and it is better than the clay bricks, the cement bricks, whatever it is. We can use this as a load bearing capacity also, because we're getting a 7 Newton for this strength. It is a first class bricks achievement, so we can use the eco-friendly sustainable building material also as it is. This is my conclusion, which I prefer, and we have done the many things and which I didn't show in this PPT. We are implementing in the real time also. We have some orders to doing in the real time projects which gettings, and we construct the small small motor house, the pump house in this local availability area which we are working. This is a pattern which I get it in Indian patterns as me and my guide, and based on this combination and the strength and everything. These are my reference. Thanking you for a sweet times to giving for an opportunity. I think everyone will enjoy this one.
Thank you so much, Nakkeeran. It was fabulous. Just have a question whether it's been ever used in a industrial scale, as in a real building, or is it just in the research step?
Actually, I didn't get you.
So has it ever been used in a building, or is it just at the research stage at the moment?
No. Actually, we are using in the real-time projects. Actually, now we get an order from one small construction, and we're planning to give plenty of huge amount of manufacture and we planning to supply on that one. Already we done one small construction in this pump house in a local area, which our research works done. So it is.
It's been really similar to our first presentation by Paul. They've been using hemp and you're using some sort of biodegradable material in the brick. Thank you so much. That was my question.
Thank you.
Can you just remove your presentation screen, please, Nakkeeran?
Yeah, sure.
Thank you. Awesome. Okay. And I shall get us back to welcome in the next guest. Okay. So next we have, we are going with, Dr. Pshtiwan Shakor is joining us from Iraq. I won't give too much of an intro because we are running quite behind. So I'll just let him get into what he has to present for us today. We'll bring you in now. Hello, thank you for joining us.
Hey, Peter, how you doing?
Good, thank you. I'm looking
Thank
forward
you.
to hearing your presentation. So thank you.
Yeah, for sure. Thanks everyone. Thanks for Peter for this opportunity, and thanks for Farid as well. So, because reign of time, I'm just going through my presentation. Okay, so basically this presentation was a published paper, and this presentation is done by me and Farid as well. I was really saying like, thanks Farid for this opportunity we done together, because we got a kind of help from a manufacturer and from Farid as well to give us some idea to our students from University of Technology Sydney through that Veena. So basically we are talking about kind of AI, like artificial intelligence, how to be used in a steel components in a manufacturing structures. Like in a manufacturers, you need to do some inspection. For those inspection, you need a kind of people to inspect the bolts and holes whether properly attached to the steel structures. So basically we have been using kind of ESP cameras, ESP32 cameras to detect those faults and errors in a steel manufacturer. So this technology is kind of new for construction, because this is being used before for different kind of AI in computer analysis. So we have been trying to use very cheap camera, like a $9 camera, and we have been using some kind of steel structures to complete our work, because one of the a manufacturer in Australia, they have this issue and we would like to solve that issue. Actually, we got a very good results with a very limited amount of money and help as well. So basically we do this one to detect the quality insurance in the old buildings, whether every single piece of steels whether will be welded together well or bolted well together, because it's need a kind of connection between each steel parts. So here I would like to say from the literature we got kind of earlier work from Park in 2015. He did some kind of work, but he really not mentioned these kind of bolts can be detected properly or not. But we would like it to introduce kind of this technology and develop it further to detect all types of the errors in the steel manufacture, for example, detecting the bolt and detecting the holes as well. So if we have any issues, we can figure out where is the problem. So we have been using kind of like a materials and technology here is like a methodology. We have been using canny edge detection, which is a kind of C++ programming language to detect all the colors and bolts together. And we have been using kind of algorithm which called RCNN algorithm, or faster RCNN algorithm, which is very helpful to detect those problems here. And combining both technologies, it gives us the problems where it's located as well. For example, if steel parts doesn't have a bolt and nuts, so they detect it straight away. So basically, the deep learning of the bolt detection, it kind of process. You need to get this process until you get the results. So this process, as you see in the image, so how you take a photos of the stuff and how you analyze it, it's all like a kind of feedback from the algorithm. So you put the input, the image and object detection, and using the selected area that you want, because you may have a lot of stuff in the image and a lot of stuff in a background, but you may need to focus only on those things that you want to detect. So here what you did, we have a kind of like an equation and to calculate those stuff, which is called m multiplied by n multiplied by d plus 1 in a bracket multiply all by k, which is meaning the shape width of the filter multiplied by shade height of the filter multiplied by number of the filters in a previous layer plus 1, all of them multiplied by numbers of the filter. If you see in those images, it can be detected by region. So, and it tells you later on whether this is a human or something else. So this is how the RCNN is work, or we can say like algorithm works. And another thing we should be considering doing this kind of analysis, we need to know how many images we have. For example, those images how can be used as well. For example, we have sometimes like 18,000 images. So some images you should put on a side for a training, which is called a training set. And this amount of training set, it should be higher than the other sets, like a test set. So if you can see here, I showed we have like a validation data, validation data set, test data set, and training data set. So in a training data set, you need a lot of amount of images, for example, 80%, sometimes 70%, sometimes 60%. And for validation data, you need less, and test data as well, you need less than that. So for test data and validation, most of the time should be equal. So we have been using like a kind of experiment on the bolts. We have made it this custom made that like a steel and the bolts and nuts. I'm really thanks Farid, she did all the stuffs by herself. So, and we just guide here. So we basically found it out how we can detect these bolts without the holes, because all the stuff is very important for us, just detecting sometimes whether we have a bolt or we don't have. Because if we don't have a bolt, we may face issues like a shear stress during the installation of the steel frames. So basically, she used two kind of cameras. She used ESP32, which is very low pixels in a camera. I think it's about 3 megapixel. The other one is they use the iPhone one. It's about 12 megapixel. So the cameras, if you have a lower version or lower quality, so you have a lower result as well. So this is just for comparison and check it out how it works. So basically in a Canny Edge, you can change your photos or your images into Gaussian filter, like a different kind of filters is like a grayscale filters can be said. So, and we have been using that faster RCNN to detect all the stuff. If you can see here, faster RCNN in here, so it have like a kind of region proportion area or network. So you can differentiated from RCN network by itself. So, and the other things we have been using, use it like a kind of SSV. So it's kind of color stuff that you need for hue and saturation, value color picker program. So, and from that point, we can detect kind of the bolts and nuts that we have. So when we have been like figured out in a different color, you can see different kind of purpose areas that you need. From here, you can see the differentiation between the cameras that we have been used. I think that, yeah, the other one, the cameras that we've been used in a SP is just 2 megapixel, which is the one is the figure, the photos in the bottom. The photos in the above is just the iPhone camera, which is about 12 megapixel. You can see the qualities of those 2 images. And we have been like detected those spots that we need, whether the frame is connected together by bolts, as tells us in a like a green color, and the areas we have been holes is just telling us in a red color. So until we can differentiate it. So for those figures, we have been using like a different kind of iteration. This iteration, if you have a more high iteration, you are getting like a higher value in a precision, which is called mean average precision as well. So we've got like for this ASP, we've got ESP32 cameras, we've got about 82% MAP, or you can say mean average precision. But in a iPhone cameras, we got very good results, and we have been using different kind of algorithm with help of the TensorFlow and RoboFlow. We have got almost about 95%. So in engineering perspective, the 83% is very low. So we need to increase that until we reach about 90 or above 90%. So we got about 95% for that purpose if we are using like a different kind of algorithm and you have more iteration. At the end, I would like to say this kind of bolt detection, so it was very successful. Even we have put different type of materials beside it, it will detect the spots that you need, and it figure out where is the bolts and the holes located. As you can see here, in green color shows us like the holes, and like a blue colors tells you where is the bolts located. So until we figure out those places that are having a holes, until we go in and check it out again and use the bolt to attach all the materials together. At the end and a conclusion of this like a study, where we have been using the canny edge detection very open, like a positive results we got. And at the end as well, the ESP cameras having the low clarity compared to the iPhone one. And these results can be more accurate if we have been using like a TensorFlow and RoboFlow to training more of the data. So if you have even more images, you get a very higher results. Thank you so much for your times. And if you have any question, you can just straight away send me the email via this email address. I'll leave the times for the other presenters to present their presentation. Thank you so much.
So wonderful. Thank you so much, Pshtiwan. Very nice work, you two.
Okay, thanks.
We'll have people email you if they have any questions. Thank you. All right. Let me see. Now, next we have Isaac is back. So we've got Isaac Akomea-Frimpong. Here we go. Let's bring you in. Could you queue up your video, please? Can you cue your actual video of yourself as well, please? Oh, ask to unmute.
Okay.
Okay, we can hear you. Now we can see you. Hello, hello. And now I can bring you into the spotlight.
Thank you.
Okay, so Isaac is about to give his presentation now. He's a PhD student from Western Sydney University. Take it away, Isaac.
Okay, thank you very much for the opportunity. It's my my presentation slides okay? Okay.
Okay,
Thank you.
yep, just make them big now and then we'll be able to see them on the screen. Do you know how to do that? Just down the bottom in the right-hand side, there's a little thing next to the slidey, next to the plus and minus, just to the left of that. Yeah, we got it. Excellent. Thank you.
Okay, so it's okay. Okay, so my name is Isaac Akomea-Frimpong, and I'm presenting on the circular economy of building materials in the Global South, a conceptual framework. I'm coming from the project management background, so I'm looking at this from that point of view. And also, this work is ongoing. So it's not everything that is 100% complete. We are still working on it. It's a work in progress. Just that the literature review on it has been developed and submitted to cleaner production, which we are expecting a good feedbacks. It's in the 3rd round, so we are hoping that it will be accepted. Okay, so let me go straight to what I'm presenting today. So I will present to you the introduction, the research methodology, the results, implications of the study, and conclusions. So globally, what we know is that waste from construction building materials create an estimated 1/3 of the world's overall waste. And at least 40% of the world carbon emissions also come from building materials. And this was reported by the BBC in 2021. In addition, 342% of waste generation all over the world has also been recorded from the building materials, according to Environmental Protection Agency of the United States government. Also, a comparative study has also been done by the UN Climate, United Nations Climate. And they put their report out there this year. And they said between 2005 and 2020, comparative to 1990 and 2004, the increment of waste from building materials has gone up by 10 times. So all these concerns are generating a lot of discussions and issues of concern around the world. In the Global South, which I will explain the Global South when I get to the methodology session. In the Global South, too, we are seeing the same problem also happening in the Global South. And this has resulted in health issues to construction workers and even the larger community, leading to lung cancer and issues, all because of waste from building materials. So currently, one of the models which has been identified, even though we have a number of models which policymakers, practitioners, and researchers are working on, one of them which has been identified to solve this problem, which I presented to you in the other slides, is circular economy. So a circular economy is meant to mitigate this growing building material waste in the construction industry. But currently, what we know is that it's not so clear in the literature as to what kind of practices, what kind of project management practices are related to implementing circular economy in mitigating waste from the building materials. So in this study, what we are trying to do is that we have developed a conceptual framework. And this conceptual framework, we didn't just only develop the conceptual framework. This conceptual framework is more of a best practice framework, which will guide the practitioners in reducing waste from building materials in the construction industry. We didn't only develop the conceptual framework from the literature, we are also trying to validate it. We want to see how it will work in the construction industry. But before I go on to the methodology, what is circular economy? Because one of the key terms I've mentioned in this presentation. So circular economy simply means trying to design ways to reduce waste and pollution by keeping products and materials in use. And after using them, you find a way to regenerate them into proper use. And this was explained by the Ellen MacArthur Foundation. This is in contrast with what we know over the years, which we normally call the linear traditional model, which is based on what we call take, make, and waste, or make, break, and discard. So in this study, this is the methodology that we are using together with my team. So the first thing I want to explain with respect to the methodology is what is Global South. So according to World Bank, and also according to a study published in 2015 by Silver, Global South in this context refers to developing, less developed, or underdeveloped nations. So currently there are 78 countries that can be considered as part of the Global South. And these countries are normally found in Africa, in Asia, and in Latin America. From here, we develop the steps to undertake this study. So the first step that we undertook as far as this study is concerned is to undertake a comprehensive literature review. So in this literature review, when we're searching for documents to help us to do this work, the key search terms that we use include circular economy, building materials, and Global South. And we were able to retrieve 98 documents. And these documents are made up of both peer-reviewed articles and gray literature. The gray literature in this context refers to literature that are from well-known and recognized as a globally recognized institutions, reports from them, and also documents, the institutional document concerning circular economy in building materials. So, we got 98, and this 98, we took them through content and thematic analysis. And out of that, we were able to extract important concept words, terms, and theories, which help us to develop the conceptual framework. This conceptual framework has been done, which I'm going to present to you soon. But currently what we are doing is that we are trying to validate it. And so far, we have been able to contact 47 experts in the construction industry from various countries in the Global South. We are hoping that by the time that the data collection, we end them, we will get more than the 47. We are expecting our target is to get at least 78 experts from the construction industry to comment on our conceptual framework. So let me go to the results. So this is our conceptual framework. Our conceptual framework is made up of 5 blocks. And in these blocks, we have the supply chain, we have the drivers, the barriers, the circular economy models or the circular models, and then the construction, demolition, and waste. The supply chain serves as the input, the source, because that's where materials come from. So here we try to look at how project managers can work on their supply chain to reduce waste in terms of developing feasible supply chain models, which can help them to tackle the waste that they experience. And then from there, we also have an aspect of the model which look at the drivers. What are the critical success factors? What are the things driving circular economy implementation in building materials? And then we also look at the barriers. What are the challenges? What are the issues related to this? And then the circular economy models. And then the output, which kind of serve as the end of this model, is the construction, demolition, waste, which is the last section of the model. Then we have tried to conceptualize or try to translate what these 5 models into the phases of a project, which is the construction project, because we believe that the construction project is bigger than these 5 blocks that we presented. Normally, construction projects have the conception phase, the business development phase, which is the financial closure phase, the design and construction phase, the operation and maintenance phase. So in all these phases, we try to look at how project managers can reduce waste in terms of using building materials. So the validation, we are collecting data, so we are the validation stage. And with this validation, If you want to be an expert who want to be part of this validation process, you must be an expert who has worked in the construction industry for at least 10 years. You must be living and working, not only living, but you must also be working in one of the countries that we consider as part of the global south. And then you must have had an experience of at least on 5 projects. So far, the comment that we have got from the validation process is that the experts are saying our model is understandable, it's practicable, and to them is relevant to the industry. Thank you so much. Our time is up. Thank you.
Thank you so much, Isaac. I'm just bringing myself back now. Hi, great presentation, and thank you very much for your patience. I'm sorry we're running behind today. Does anybody have any questions before we move on to the next? No, nothing's coming in at the moment. If somebody does shoot something through to the Q&A, you can type in an answer to them down the bottom in the question and answer box. Thank you again, Isaac, and
have a good one.
Thank you. Bye.
Bye.
Okay, so up next, I think we might have Shadyar. Where are you? Okay, no. Oh, there you are. I lost you for a second. Hi there, Shadyar. Nice to see you again. Oh, we have no audio. Oh, sorry. I think I need to maybe unmute you or something. No. Okay, say something for me and see if we can hear. Or nothing. Can't hear anything still. Oh no. I know it's not muted. I'm not sure why it's not working. I'll try and mute you and then ask to unmute. Okay, we'll see if this works. Oh, still nothing. Must be a speaker. I'm not hearing anything. Sure. Yep. We were delayed to the next person. No worries. Okay, so let's see who is up next. Sorry about the technical little itch there. Okay, so we've got next is Satvik. Is he here at the moment? Oh, Hedwig's here. Hello. No, he's not here at the moment. So let's see who's next. Then it would be Mark, and Mark is with us at the moment. So I am going to cue you up now, Mark, if you're around. Let's get your video happening. Here we go. We've got some visuals happening now.
Yes.
Here we are. Hello, hello.
Hello, can you hear me there?
We can hear you. This is good. I
Excellent.
think maybe he might have had the audio might not have been enabled or something. I had that issue when I checked in. No one could hear me, and
it's the life we live in. Yes, I'll
right.
just share you a screen there.
Fabulous. All right, so we've got Marco Dwyer here from H2O Architects down in Melbourne. I'm not going to do a long hoo-ha, but he's one of Melbourne's leading sustainable commercial architects. So he's worked on a lot of very interesting buildings and has some interesting stuff here for us today. So take it away, Mark.
All right, thanks there, Pieter. That's all sharing for you, is it all?
Yes, we've got your screen right there, and we
Excellent.
can see your face to the right of it. It's fabulous.
Thanks for that. Well, what I'm going to run you through today is it's actually a culmination of a number of years' work. This image here is a factory of the future we did back in 2016 at the emergence of sort of digital printing of objects, 3D objects in all sorts of formats. And it's this beautiful little fit out we did over those years that looked at all of those approaches. And we've expanded that now to include concrete printing. So we've got a fit out next door where we do big object concrete printing, as well as metals and plastics and the like. So that's a bit of the concrete printing approaches there. Now, all of this technology since then has obviously now filtered right through the world in terms of Australia, Asia, and into wonderful setups within the United Arab Emirates and the UK and the US. And what interested us is that Swinburne were wanting to do a fit out for their students to start integrating these parts into their work. So we thought, look, a key part of that would be let's start integrating their outputs from that into the built product. And that's critical, because we're starting to build a picture that Australia is lagging behind a lot of the world in terms of integration of these approaches, because it's just not seizing the opportunity of the sort of advances that have been done in the technology and where they might lead. So we thought, all right, if we can make that bridge from academia to construction, where in academia we can start as part of the coursework, get the students to design some of the parts of the building, and then as part of the delivery of the building, we'll put those parts into the built product and start to showcase them. So it really becomes an active part of what students do in terms of how they look and see and feel things. So as you see in this image, we're talking about acoustic baffles for the building, signage for the building, furniture, light shades, they're all in there. And I'll show you a key part that we've been focusing on, and that's the external facade of a particular part of the robotics of the building. We think that's key because it starts to put the ideas of what these technologies can do right in the front and center of the public domain and start that discussion. So it takes it out of being just another product that's done as a nice little surprise at a home office or in some fringe work that's on the outer suburbs, and starts to put it into the public domain. So this broadly is a parametric setup of the fit out of what we're doing for the fabrication laboratory. So what it is, it's a whole area where you work in different types of formats for digital fabrication, architecture students, TAFE students, design students, interior design students, working to start to understand that whole sort of nose to tail part of coming up with the idea and then executing it. Still has some of the old school approaches of working with sawn timber and those sort of approaches, but right through to a digital setup on this end where a robot milling facility is being relocated into this new box we're putting on the end of the building. And that's where we start to say, let's showcase these aspects of what the students are doing. So that box, in essence, as you're seeing in this image here, it is essentially a glass box, so much as you see there, a basic glass box with a roof on it. And to that, we then start to apply a skin of steel to support a series of clip-ons that then are part of the panels the students are designing. So there you see it in sections. So essentially it's a glass box, and then there's an exoskeleton of concrete or steel manufactured parts, much as you see there. So it becomes both a showcase that can be changed over time because it's all set up by a modular system of panels. They can be screwed and unscrewed through the life of the building, so we can adjust the sort of products that students are doing and change them over time and start to show some of the creativity going on. This is just an example of what some of the students are coming up with. This is the steel approaches. Pausing on that, all of the composites are either metal or concrete approaches because of flammability index requirements. One of the complexities of work like this is taking something from a student domain or an academic domain, putting it into a facade material like this. It has certification requirements, and part of that is it has to be non-flammable. And how do you prove that? Well, you go through a performance approach in order to allow it to be that approach, because it won't have full certification like other materials that you use normally. So a little complexity to dwell on. These are some of the concrete ideas that are coming out from the students, again, all digitally fabric designed and then built by robots as part of the screening. And what that'll be is you'll see this facade here eventually will be covered completely in those sort of outputs in what we see in all sorts of games. Where we are on the journey at the moment, we're just going through the assessment with the students as to who and what people are going to be manufacturing the different parts, so we can then apply that to part of the design that's going to start construction at the end of the year. So on that part, I'd like to say thanks to Peter and Farid for bringing me along to this excellent webinar.
Oh, you were so fabulous. Thank you so much for that. That's very exciting. You know what? This actually ties in with our next guest as well. So here we go. Oh, we're in there together. Hello.
I'll say thanks, Mark, as well, for coming along.
Our next guest is because we're still having some technical issues for Shadyar, but we can move on to Hedwig, who is over in the Netherlands. Oh yes, we can hear you. Hello.
Oh, brilliant. Hi,
Oh, good.
hi.
Okay, no more
Great.
technical issues. Sorry, Mark.
Yeah,
I'll bump you now.
sorry.
Thank you, Mark. And now let's get your visuals up.
Sure.
I can't see your face just yet.
Can you
Oh,
see
there you are. Yes, yes, we've got
Great.
you. I'll bring you on in now. Hi.
Hi, hello.
Okay, so now we're through that little issue. So let's give you a quick introduction. This is Shadyar Idris, who is a student, a civil engineering student from over in Iraq. He can take it away now and give his presentation.
Thank you.
I will move.
Good introduction. Okay, hi. Let me share. Okay, hi, hello. As Peter said, my name is Shadyar Idris. I'm from Iraq, and the title of my presentation is Crack Detection on Concrete Surfaces using Image Surfaces. So there are many other methods to detect cracks in concrete, such as infrared and other methods. I chose image processing. That's basically the data that I give to the model is images. Okay. This is the table of content of my presentation: an introduction, the problem that I'm going to solve, result, and finally conclusions. If we see introduction, imagine there's a big building or big building that's made of concrete, and we want to measure its safety, its health monitoring. To do this, we need to do it manually. Today we need to do it manually, but that's very labor intensive, and it costs quite a large amount of money. So I'm trying to solve this problem, as you can see here. This is the statement of problem that I'm trying to solve. We're trying to create a model that can automatically detect cracks in concrete surfaces and basically automate the process. As you can see, this is the manual method. It needs an expert to go to the site to label the crack and its direction and such things. And this is a very subjective work because every person has certain expertise in the area. But we're trying to solve this to create a standard model that can detect the concrete crack without any labor force. Okay. In previous work, we have this paper, for example. It's a paper that uses YOLO V2. YOLO stands for You Only Look Once, and the 2 is version 2. This paper is by Dung and his colleagues. His paper basically focuses on distinguishing between cracks, as you can see here, and handwritten scripts. That was his model. My model is different from this and other previous models, is that you can detect the direction of the cracks, not just the cracks, but also its direction. Because direction is important. If we know its direction, we know why the crack has formed, the reason behind it, and can address the issue and the maintenance much better if we know why it has been formed. And now I'm going to talk about YOLO. YOLO is a model, an algorithm that has been developed first by Joseph Redman in 2016. But since then, it has gone through many iterations, many versions. The latest one being version V8, version 8. And also a very unique feature, very important feature of YOLO is that it can detect in about 91 frames per second, which is brilliant because we can use it for videos. For example, if we give it a video, it can detect the object live. It can detect object live without any delay. And this is the detail of YOLO V8. This is the name of the model. I actually have two models, bounding box and segmentation. This is some details of the segmentation. It has about 261 layers, more than 11 million parameters and gradients. Also, an important part of the model is these parameters. These parameters we can edit, we can alter. How do we like? For example, we have the image size, which the default value is about 640 pixels by 400 pixels. And we have the batch size. Batch size we selected 16. Batch size is basically when we train the model, it goes through 16 images at once. That's the batch size. Then we have epochs. Our model, we got 300 epochs. Epochs is basically like iteration. If you see this, I'm going to talk about it more later. Now I'm going to talk about methodology, how to create a model like that. First of all, we need a large data set. We could take pictures of concrete tracks by our phones or anything like that. It's okay. Any sort of picture is fine. Then we need to annotate it. As you can see in this picture, this is the crack, and we draw these dots around it, and it forms this shape of the crack. This process is called annotation. For example, if you have 900 photos, you should do this for every 900 photos. So it's quite some work. In the next step, we have pre-processing. When we take many images, the sizes can be different. For example, we have full HD images, 1080p or 480, different image sizes. So when we try to import the model, we should first pre-process it. We should convert all the size into one shape. As I said, in previous detail, we selected 640 pixels by 660 pixels. Then we create augmentation. What is augmentation? Augmentation basically creates images, more data from our current data. It generates more images. For example, we apply, for example, 25% grayscale. For example, we have 100 images. It generates 25 images, new images, but they're gray. That's augmentation. It edits our, creates more images. Then after that, we train the model. The model basically trains automatically, and it takes time. For example, it can take hours or days. It largely depends on the model and the data set. We saw this image. As I said, I have two models. I have created two models. The first one is instant segmentation. The second one is object detection. Object detection is rather basic as compared with instant segmentation because it only draws a bounded box around the detected object. But instant segmentation is more advanced. It basically highlights the crash, its entirety, its shape, and everything. I'm going to show you more differences later. I'm going to talk about the results. This is the mean average precision of our model, the bounding box model. As you can see, at first, its precision, this is precision, it's very, very low. It's about 0%. But then it reached a height of about near 90 precision. And also these are drops. As you can see, as we go higher, when we go to higher iterations, latest iteration, the drop basically lower, decrease or lower. And when we create images, the data set, and when we annotate it and everything, it creates a heat map. For example, my model basically creates 3 types of cracks: that vertical, horizontal, and diagonal. This is the heat map for vertical, and this is for the horizontal. As you can see, it's a horizontal shape, and this is for the diagonal one. I'm going to talk about results. This is an image of some prisms. As you can see, when I applied the model to it, it detected most of the cracks. As you can see, it detects this a diagonal crack, and it's 91% sure. And this is another diagonal. This is the bounding box model. As you can see, it only draws a bounding box around it, nothing more. But when we look at this is intersegmentation, it draws the exact shape of the cracks, and this can be very crucial to some industry or work. Now I'm going to talk about the performance in different lightings. This is, let me enlarge it. Okay, we have these are all the same crack at different lighting environments. This is for the intersegmentation, and this is for the bounding box model. As you can see, as the darker environment produces much more confidence levels, high confidence levels. For example, we have 86 here, we have 88. Even though this it detects the crack exactly, but it says 2% sure, which is very low because of the lighting condition. And also when we look at the the bounding box model, it detects much better. For example, you have 71% here and 69% here instead of 2%. Another important unique feature of my model, as it can detect more than 2 different types of cracks in one image. For example, we have this image for the bounding box. It shows the 2 types of cracks, horizontal crack and the vertical, and the same thing for the intersegmentation model. And if I try to end my presentation with this conclusion, first of all, I would like to say that manual crack detection is quite intensive because we need experts to go to the site to basically highlight the cracks and see how large is it. And the second point of the conclusion, annotation is by far the most important step in creating a model like this. Because when we create a model like this, when we annotate the cracks or the object, we teach the algorithm, that's the mode, that's the object, that's the crack, that's its direction. So annotation is really, really important. For mean average precision, as Dr. Pshtiwan talked about before, for object detection, we have an MAP of 87.1, and for intersegmentation, we have 88.5. And if you have any questions, you can send me an email, because I think there's not much time, but if you want, you can still ask questions, anything you like.
Fantastic. We'll we can get them to put their questions in the Q&A.
Sure.
So if anybody writes something in there, you can just type in an answer to them as well.
Sure. So Mr. Farid.
Oh yes.
Is there any actual image of the device? Actually, we don't have a device. We have a model, a computer model. We basically took the images by iPhone cameras and put it in the model. There is no specific device that can do that. And also, yes, it's a normal camera. And cost of operation. This model is still in research phase. It's not industrial, so we don't know the exact cost of operation. But I'd say it's much lower as compared to the manual inspection, because we do not need to pay them salaries, for example, or we just need some robots and goes detects the site and detects the cracks, and that's pretty much it.
Good morning. My name is Satvik. My topic is apprising the consequences of sleep deprivation on construction labor productivity using wearable biosensors and ISM methods. Introduction. Construction is a labor-intensive process as manpower is one of the productive resources in construction. Thus, productivity largely depends on human performance. Labor productivity in construction largely depends on majorly two factors, that is, size and type of the projects completely. The factors which are affecting labor productivity are labor organization, management, real wage trends, and one of the major vital factors is sleep deprivation. What do you mean by say sleep deprivation? Sleep deprivation is considered to be loss of sleep on insufficient sleep, which results in problems such as poor concentration or irritability. Then a condition of body and mind which typically recurs for several hours every night, in which the nervous system is inactive and the eyes are closed and the posture muscles are relaxed, is considered to be sleep. Then the sleep length is associated with subjective and psychological sleep well-being. The symptoms of sleep deprivation are inattention, droopy eyelids, and general discomfort. This is a statistic Bureau of India where the people are being affected by the sleep deprivation in different sectors. Then there are different types of sleep deprivation, such as acute sleep deprivation is one night or too few nights without sleep is considered to be acute sleep deprivation. Chronic sleep deprivation is without sleep for weeks, months, and years is considered to be chronic sleep deprivation. And then sleep apnea is breathing repeatedly or heavy snoring or feeling tired after sleep is considered to be sleep apnea. Types of labors are skilled laborers who are having specialized training or skills, semi-skilled labor. Yes, sir. Semi-skilled laborers doesn't require advanced training, and unskilled laborers are having lack of specific skills and highly improbable. It takes about 4 days of time to recover 1 hour loss of sleep in a human being. Then, as we're using wearable biosensor, in the wearable biosensor, we are using Fitbit watch method that is being collected from the laborers in 4 intervals.
To be,
Is there anything else you had to add at all, Mark, while we wait for Hedwig to pop in? Because yours was quite cut off, wasn't it?
No, it's the way of life. No, Farid had a question there of that thing I alluded to of how do you get certification or some sort of formal process for objects like this that are emerging. So it's a good question for it. It's complex because codes and regulations haven't really caught up with how the world's developing with these products, because much as you know, the materials that they're made from and how they're made and what they are is emerging, and it's quite various, particularly the concrete ones where the mixes are usually a specialized mix to allow that plasticity for them to then be pumped out in that printing process. Right. So we've found the best way around that is to get a compliant group of both building certifiers, but more importantly, a facade contractor or consultant that'll end up reviewing it from first principles. And so they'll take it all back to the beginning. To go through a process of formal testing is both expensive and time delaying for these sort of one-offs. But if you get facade consultants, they review the mix, they review the characteristics, they review what it's trying to do.
I'm thinking about, like, let's say having a land release approval from a local council. And they're definitely asking for a method of construction, which 3D printing is not one of them at the moment.
No.
So based on your recommendation, facade constructors, facade regulated bodies must have prepared something and then disclose it probably with the local councils.
Yes. It's because if you look at building certification or any form of certification has a whole group of registered building surveyors that approve these things, and they look at what's called deemed to satisfy. So they say, is it meeting the codes and regulations and then it's called deemed satisfied. They always have the ability to go a performance approach by an outside party looking at it from first principles, which is just one of the beauties of the Australian process. And so it's finding the people that have got the time, the effort and the smarts to go down that first principles performance approach is the short version. Does that answer your question? Yeah.
Yeah, definitely. I was just wondering about how does the process work traditionally in Australia throughout the past.
I think we've got the next speaker.
We've got her. We've got Hedwig in the house. Hello. Okay, we're bringing you in now, my dear. 1 second. And thank you very much for filling in for us there, Mark. Hi there.
Hi, I'm so sorry. I thought we had a longer delay, so.
Oh, there was, but we lost a person. So that's why we're kind of caught up a little bit now. Thank you so much for joining us. Everyone, this is
happy to.
Hedwig Heinsman from over in the Netherlands. Very, very cool stuff happening there. So Hedwig's actually the co-founder of Actuel and how do you say, is it DUS or DUS or?
DUS.
DUS, yeah.
Yeah.
Nice. So they're basically disrupting the global AEC industry with circular interior on-demand platform. So they're also, I don't know if that just went a little bit hickledy-pickledy in my in my script there. But anyway, you let us know the amazing things you've been doing and I'll leave it to you. Thank you so much.
Thank you. Let me see if I can share my screen. Yeah. Can you see it?
Yes, I'll just unmute. Yes, we can see it. If you can put it into the big screen. Yeah.
Perfect. It works now.
Thank you. It should be black at the moment, but I feel like it could be loading or something.
Yeah.
Oh yeah, there's a little flash.
I think maybe I'm going to keep it in this mode, if that's okay, because then I think it will work better. It's a lot of big files. So Actual indeed is a platform for fully circular interior products made via large-scale 3D printing of recycled waste materials. And what most people don't know is that we really are two companies in a way. So on the one hand, we have our digital parametric design platform where we develop all kinds of configurable products. And we also have our own in-house developed proprietary 3D printing technology, but we also now license to partners. And sorry about that. My daughter is just walking in. Lois, you have to go away. Sorry. So the AEC accounts for some 40% of all global carbon emissions. And as you all know, and also about some 1/3 of all the waste in the world. And that's, of course, really a bad thing. And what most people don't know, but what is just as worse, is that interiors actually are incredibly polluting. As Actual, we really try to find a solution to the recurring waste that happens in the interior industry. For the sake of time, I'll go a bit quick, but we have our own 3D print facility in Amsterdam, and we now also more and more print also in other areas in Europe. That's really exciting. We print with several materials, for instance, plant-based plastic that we developed with Henkel, but also now the recycled inner foils of drink cartons made in collaboration with Tetra Pak. We have loads of great clients, and we also work with great architects. And the nice thing is that also more and more press is picking up on what we do. And recently we got a great article in Forbes magazine calling what we do the ultimate upcycling approach. So how does it really work? Our clients, architects, but also contractors, projects developers, they can go online and they can pick a product or a system and they can totally configure it to their taste or regenerate it for them, so that the products are totally fitting the interior design. Then a 3D print file is generated and it's then 3D printed on demand. Then the products are finished and they can be picked up or transported to site, and then the local contractor can install it. And after use, we make sure that the elements are taken back and they're shredded by partners, and then it can be reprinted. And in theory, this process can just repeat and repeat. almost infinitely, depending on the kinds of materials that you work with. Some materials you can recycle without adding any new waste material for at least 10 times, which is really amazing. So on the one hand, we have configurable objects like poofs and planters. And on the other hand, we have architectural finishes, so all kinds of wall panels, room dividers, screens. And I'll show you a few. So for instance, a weave system that's almost like, it's panels that appear almost woven. And this is, for instance, a way that's been applied by Nike. But also here you see it used as a temporary canopy for the Dutch House of Representatives in the Netherlands. And in a few years from now, when the historical House of Representatives is finished, after refurbishment, then this entire canopy will be dismantled and it can be shredded and it can be reprinted again. And what is nice is that you can make all sorts of very intricate details. For us, that's very simple because it's all digitally developed. But also the same system can also be applied on a much smaller scale, for instance, here as a acoustic absorber, because then there's also a PET felt added to the back structure. Another example, these are sound wave panels developed by Camacho Köhler in collaboration with the ETH in Zurich. And these panels, they diffuse sound. The shape of the waves is made in such a way that it really optimally diffuses the sound waves. And the nice thing is that these panels are now also applied already in several projects in the Netherlands. So not only now in the ETH, but also more by commercial clients. So we also really try to find new economic models for architects to sell their innovations. All kinds of panels that allow to create custom shading, because of course every panel that we print is custom. So it's very easy for us to make custom panels and patterns and logos. And we do a lot of these screens for hotels, for instance, and restaurants, but also fairs. And what is interesting, of course, that sadly enough in fairs, there's a tremendous amount of waste. But in our case, after the fair, we take the materials back, they're shredded and they're directly reprinted into new materials. An example of a permanent exhibition interior at the Future Museum in Dubai by Atelier Bruckner, a German architecture firm. All sorts of other screens that almost appear crocheted. So I think it sort of speaks for itself. What's really interesting is that you can suddenly really generate an infinite amount of design instance with our parametric designs, and you can really tailor make it. So about the printing, we really see it as a craft. It's not a matter of pushing a button. It's really a lot of R&D. And this is, for instance, how we started printing with our plant-based material. It was almost like a kind of syrup, and it really took us more than a year before we really sort of mastered the material. But now we really know about all the properties of various materials, their heat, their speed, but also really the properties of products, so the UV resistance, fire resistance. And that's why now we have all kinds of certified products, like for instance, our wrap paneling, which really you can print and then in a way that it wraps around the building. So we create loads of planters and wall panels. And what is nice here is that you see in this render, that is very exciting for an architect and an interior designer, that they can really suddenly really create very tailored designs, very much to their own taste. All kinds of office meeting solutions, very big planters, and it goes on and on. Roofs, also flooring, that's a combination of a terrazzo with a plant-based binding agent and real marble and printed patterns that we make. So you as a designer can create any kind of pattern with our tool, and then it's 3D printed in segments. And those segments are then brought to the site and they're welded together by heat. And then you get these really big surfaces. And then the terrazzo is poured and sanded back. And then you get these really nice floors. This is, for instance, a small project by Zaha Hadid Architects. The previous was by Patricia Urquiola. But also some examples by Nike, for instance. But perhaps my personal favorite is more meanwhile use. So really bigger objects, small architecture. And I think that really the commercial projects of Actual are about 99% all interiors, but gradually we more and more also step to the built environment. So we're currently developing facades and also these pilot projects, like for instance, this urban cabin, where we tested all kinds of ways of connecting joints. How can you insulate with the material by 3D printing air pockets, for instance? This was a tiny Bauhaus that we printed 2 years ago when it was 100 years Bauhaus, and it traveled Europe. And also here you see all kinds of products that we developed. I think I'm almost out of my time, so just a few more pictures.
I was about to say just to take your time, because we don't have anyone after you right now. The other person hasn't shown up, so you can relax, so you can actually get a breath.
Okay, that's good to know.
Waiting for a moment to say it's okay.
Okay, good. Yeah, because okay, good. Thank you.
You can when you take your time. Thank you.
So what's nice, I think, about this urban cabin is that it's, or this tiny Bauhaus, is that it really combines a lot of the products that we have in our portfolio. But I think it also shows really what's so great about 3D printing, apart, of course, from the sustainability aspect, which is the major thing, but also that you can almost make a kind of Gesamtkunstwerk, like a total work of art, so that you really can create details that connect to each other. And, you can create canopies that can really protrude from a wall, or furniture that can really have a relationship with the building. And so in that sense, it also brings a lot of architectural freedom. I think that's really exciting. So a glimpse of our factory. As you can imagine, it's getting crowdier and crowdier. So the great thing about printing, of course, is that you can send files digitally and then get it 3D printed also locally. So that's something that we're currently really focusing on as a platform, which is really exciting. So who knows, maybe in a while we can either offer our products directly 3D printed in Australia, where we can collaborate with local partners. I already saw some interesting examples in the previous presentation. Maybe I think it's also good to emphasize the notion of circularity. One of the great things about 3D printing is that it's very easy to shred the material afterwards, and then it can directly be fed into the printers. And this also doesn't require a lot of electricity or other steps in the process. So it's literally the shredded material that directly feeds into the extruder. Most materials that we print with have a life cycle of some 7 to 10 times, and then after that you can still reuse it, but you have to add a certain percentage of new waste material, some 10% most of the case. So in that sense, it's a very interesting circular loop that we facilitate, and that's also now something that as a company that we really offer. So that's really exciting. So on all our products we have a deposit, so clients can get the material deposit back when they return the product, or they can get a discount on a next purchase. But something that, of course, is even more exciting is that in the future, hopefully, we can become something like a material bank, so that people can really subscribe to a product and basically just lease the material and an X amount of design iterations. And that's something that we're currently investigating. And on a small scale, sometimes we already do that. So this is a small example of, for instance, a project last year where we did with Hermes. So this was a kiosk, a temporary kiosk, and it will reincarnate again somewhere in the future. And on a bigger scale, I think this is quite a nice example. This was a pavilion designed by Pragma Architects, and we entirely printed it last year for a horticultural exhibition here in the Netherlands. This was the UAE pavilion of the United Arab Emirates. And the white claustra wall that you see here, and also the green facade panels, they were printed by us. And the building was there for 9 months. And after that time, we took all the items back and they were shredded. And they now already have been, the material already has been reused in all kinds of new products. So this technology also really facilitates a new kind of, I think, ephemeral architecture, which can really cater to local needs. And then also then again, just, reincarnate into something else where it's more needed. And I think that's really fascinating. That's it. And we're always happy to collaborate with new architects and new manufacturing partners. So when you're interested, please do send me an email or reach out in another way. Thanks.
That is so awesome. If Mark, do you have any questions for Hedwig? Do you have anything that you two want to chat about in the presence of others?
Just fantastic to see how well developed it is, and that was sort of the intro of what I said, that I think Australia. Well, I'll rewind. We did our first 3D printing facility back, over 10 years ago. And it's just sad to see that Australia's still at the starting gates when the rest of the world's moving so well, as we can see there. So it's part why we're trying to encourage the groups we're working with to start making it more public, start working with the students to really excite them and get it out there, as opposed to just dabbling in it. Because this is exactly what the world's headed for. Really wonderful work, Hedwig.
Well, thank you. We always love to have students in our team. It's really nice that after COVID we can travel again. So if people are looking for an internship or just want to come and visit, they're most welcome.
Yeah, I'll be dropping in next time I'm over.
Yeah, you really have to.
So wonderful. We're making connections here, people. This is so great. Thank you both very much for your time. I wanted to make sure you had a moment to chat to each other, seeing as you had something in common a little bit there. So well, thank you very much for your time and, joining us on the other side of the world, Hedwig. Distinguished guests and participants from around the world, we've reached the conclusion of the 6th International Webinar on Construction Materials. It's been an incredible day filled with insightful presentations, engaging discussions, and the exchange of innovative ideas, as we've just seen. On behalf of the organising committee, I want to express our deepest gratitude to all the speakers, panellists, and participants who've made this event a resounding success. Throughout the day, we've witnessed the power of collaboration and the collective passion for advancing the field of construction materials. The knowledge shared here today will undoubtedly pave the way for a more sustainable and resilient built environment. We also expressed our gratitude to the participants who actively engaged in discussions today, asked thought-provoking questions and shared their valuable perspectives. It's through your active participation that we've created a vibrant and inclusive learning environment where ideas have flourished and new connections have been forged. Thank you again all for your time, and it is now getting dark where we are and is the morning for some of our other guests. So have a wonderful day or evening, no matter where you are.
Thank you so much, Peter.
Thank you for having me. Okay, goodbye, everybody.
Whoever said that's so impossible? Well, that's not supposed to go there. Doesn't know me well, 'cause I know that today holds more, yeah, so much more.